we live? Oh, I didn't set up the thing I need. I'm not on Twitch. Uno momento while I figure out if you guys can even hear me. I'm obviously prepared this morning. Okay, it looks like... Hey, Sarade. Sarade says I can hear you. Legendary. It works. This thing still works. It's called OBS. Legendary. What's up, Sarade? How's it going? Oh, man. I'm just reading the names of people who followed in the activity feed. One, I'm gonna say them all, but you'll know which one I'm laughing at. There's Basher Zombie, Cody Ark, Bit69 Treem, Poonslayer X69, Yiji, Kayashav, and then Ariston. Thank you all so much for the follows. while I was offline. Oh god. Is this Call of Duty? What are we playing? MW2 all over again. Jesus. Let's just start programming before I get too distracted. So it says, I'm currently adding unit tests for my URI parser. That sounds like the worst possible thing you could do. So it says, this is about to get painful, lol. Yeah, you think? Do you think? I think it might be rough. Yes. We're here. But we're not here. That's right. There was a poll request. Also, I gotta make an announcement. See, I'm already getting off track. I'm getting at least slightly better on the keyboard. It's... I'm so dumb. Not a compiler. There we go. And we're live on https:/twitch.tv/Lenser. I'm in a mood today. Jesus. Okay, I made the announcement. Also, if you don't know, join the Discord. It's great. We got a lot of people, even the Terry Davis himself, apparently. Okay. Anyway, a lot of people. It's a great idea to join. I'll wave at you, and we'll all have a good time. You know what? I just realized you can't see it. Oh, I'm out of whack. Okay. I just made an announcement. There's an announcement every time I go live. I wave every time, and yeah, we all have a lot of fun. We even have Terry Davis himself. This is what I was looking at. It was so good. By the way, is the stream title correct? The stream has a title? Do I have to do something about that? It's not. This would be... It's a compiler. Wow. That went very wrong. It's a compiler, dude. That's what we're gonna do. It's a compiler, dude. That's what we're working on. It's a compiler, dude. That way, people can know. Next up on the agenda, there was a poll request to the fun compiler. And it was me. Oh, you said tests failed, 19. Great. That's about how unit tests go for me. I did some off-stream work, but hear me out. It's in a pull request, so we're going to go over everything I did. Don't hate me. And this pull request will be forever available for you to see the diff of. I also updated the developer's manual a little bit in preparation. Okay. In any case, mainly what I did was go through and fix bugs. For example, when we created a call, we never actually called the things that create a call instruction, which meant that when we were marking uses in the IR itself, right, in IR direct call and indirect call, when we added the use marking, it wasn't added here in the codegen.c, which meant that we weren't getting proper uses of function calls, which was kind of not ideal. But that's fixed now. I went through... Thank you so much, Saraid, for helping me out. You're working on a URI parser, having tests fail, and you're like, oh, by the way, your stream title's wrong. And yes, I can hear you. You're like the most helpful person in the world. You're doing everything all at once. We had a copy and paste error, it seems, where I only changed one of the arguments from otherwise to then. And that meant that, you know, the then return value with the last otherwise block makes no sense. It's the last then block and the then return value. That has to do with the if code gen. The branch was only being inserted when it was a non-empty if statement. So empty if statements would cause a whole bug where they would just like execute where they shouldn't because there's no jump. So you know, that's been fixed. That's been fixed. And yeah. We now branch outside of the if is all that changed there. We no longer print as much stuff, so we're going to remove set IDs and femit and stuff like that. Instead of, this isn't right, we just move this down. Git sucks at formatting a diff, apparently. We didn't remove IR insert. So set pair and mark. What are you making a URI parser for, Saraid? Set pair and mark basically says set the left-hand side and the right-hand side of the parent, and then mark used in that parent, so that the left-hand side is used by the parent, and the right-hand side is used by the parent. And this just makes it easy for all of our pair-based, like binary tree-based instructions to use the same set pair and mark function, which means we don't have to remember to mark used after doing this. We can just call this function and everything's golden. So it says, I'm writing a networking library. Oh yeah, as someone sensible would do. What? A networking library? Is it? Lenser OS is going to have a network stack in no time. We'll just support the syscalls that you need. Ignore that. Sorry, it says, nah, it's user space, haha. Yeah, we'll just support the syscalls you need. Boom. Network stack. Okay. IR insert got moved down. That's all that happened. And it did get changed. The contents of it got moved IR insert into block, which is just the context block. And then IR insert into block. Look at this weird diff, man. So the contents of the IR insert basically just went here with a little more checks. So it says a TCP SSL wrapper and an HTTP client server, basically. I'm writing a networking library because I need one for not one, but 3 other projects. Oh, Christ. Okay. We added some helper functions here. They were previously in register allocation.c. I just moved them, which is insert instruction before and after. So now that's in ir.c and ir.h. We never handled the local store printing, so I added that to IR femit. Register and stack allocate are now new IR types that are needed for the x86-64 lowering in the backend, and a lot of other backends will need them, I presume, as well, so I just added them as types. It's okay to have extra types because it's all a union, and we didn't have to make the union bigger to add this, so it's like, it's effectively a zero sum. Like we added 2, but there's nothing actually added to the struct. It's cool. Just more names for the same things. IR block attached to function, we basically now separated IR block attach. It used to use the context function hard-coded, which meant that if you wanted to attach to a different function, you had to change the context function, and it was a whole mess. Instead of doing that, we just have a helper, like the implementation, attached to function, and then we have IR block attach, just call this IR block attached to function on the context function. That way, if you want to add to another function, for example, in register allocation, we do that all the time. It's very easy. You just pass in the function in the block and it attaches it. How beautiful. Call instructions. This is IR direct and indirect call. They no longer insert themselves because we have to add the arguments, and we need to generate the arguments before we insert the function call, obviously. So that's why that has to happen that way. And that's previously why we didn't use this function, but instead we should have just used this function and then, removed these, as you see here. You are a busy man, Sarade. 3 other projects, a networking library for all of them. That's incredible. That's more than I got going on. And I'm writing an OS. Local store, so here's an example of how simplified the set parent mark is. All of these get turned into just one line, and it's fairly simple. Most of it's just pointing out the parent, where to go, and then the everything else. I don't even know if this is used, to be honest. We could probably condense that. But to keep it general, it's not bad. So it says lots of IR insertion functions, of course. Yeah, I made it a bunch of helpers to make it easier to insert things, because man, it was rough doing this all by hand in register allocation. I was like, I gotta help myself out doing all this stuff. So now we have set parent mark, we have branch into block, which means that you can just create a branch to a destination block from a block given, and then you return branch, and then you can no longer insert because there's a branch, and the basic block has to have one branch and at the end. Another example of where we weren't marking uses, as you can see, no use marking. So with this new set parent mark, we now mark uses, and everything is good for register allocation. Yeah, a lot of backends have these instructions, but the IR isn't generated with a minute. This is the IR register and stack allocate. They're useful. A lot of backends need them, so you might as well add them. But they're not actually generated. We have the use structure, which just moved, I think. I don't know why they said we added it. We just moved it. Here's set parent mark as well. We added a function pointer to the IR block so that you can go from instruction to block to function. We have a helper. This is all just the headers for everything we just went through. Error got moved from auto-inserted quotes to a nice system header include. Here's where we moved instruction before and after from. What else? That's right. We fixed, we at least fixed a major amount, the function call arguments. Because we can know, basically we would check for an error after heap allocating something, but it has nothing to do with the heap allocation, so why do we wait until after a heap allocation to check for an error in the loop? So we check for the error first now. Pretty sure that's fine. Because this has nothing to do with these at all. So we now check for this at the top. I think that's all I moved. Yeah, and then we just used this twice. So I just made it a variable to make it clear. We have the register allocation needs register. So not every instruction needs a register. Only these ones do. Funnily enough, the phi instruction needs a register, but it doesn't correspond to any hardware function. Isn't that funky? But yeah, so these are the ones that need to register. For example, the result of an add, the sum, a subtract, the difference, a load, a local address, a global address, a phi, a copy, an immediate, a comparison, a call, and a parameter reference. That's all you get. All the rest, they don't need it. I should probably put an assert here, like a static assert, with the amount of IR count being as it is, but it's fine. And then instead of doing this switch in all of the functions that need to do it, we now can just say if needs register in register allocation. We removed this just random check, and we made it an assertion, because we then go on to like dereference it a whole bunch. So I'm not sure why I thought this would help, but that was my error handling at the time, so that's been fixed with an assert now. And we basically have all capitals versions of the print functions in register allocation, and they are only defined as the print function when the register allocation is debug. So now you can just call these. This is an idea I stole from Serade in Lenser OS, but now you can just call irf emit, and for example, it will only irf emit, and because it will expand to the irf emit call only when debug register allocation is true, or defined at least. And then there's just a commented out debug RA at the top somewhere. There. So you just uncomment that, and then you get a whole bunch of output immediately. And when you're writing the code, you don't have a bunch of stuff. Sorade says you could put these all in one place to save space. Yeah. I just scrolled through the file in Emacs and kept updating them as I saw them. But you're right, they should all be in one place. That'd be more understandable. This all moved upwards because we needed it static due to lower, both being static and needing to access the same variables that were local variables, and I didn't really want to pass like the register allocation info to lower and stuff like that. We could, but then we'd have to create the register allocation info and make it, and then call lower, and then call register allocation, and that seems like a really finicky process. Calling lower right away just on the IR seems like a better way to go. So that's what we do. Anyway, we still have to set up the argument registers and stuff, but it makes sense that you have to set up static memory with the proper things before moving on. Sorade says, also unrelated, but you know you've been working on something for too long if you start remembering the RFC numbers, lol. That's definitely you've been working on it too long. So if you don't know, lowering, this just refers to taking the IR instruction set and lowering it, in quotes, to something that the x86-64 backend can understand and actually generate code from. So, for example, it will take a parameter reference and it will convert it. What is a parameter reference? There's no like guaranteed place where you can find a parameter. So the compiler, the x86-64 backend, has to make a guaranteed place to find the parameter, and it does that with the stack allocation instruction. Currently it just allocates 8 bytes. That's probably something we should fix. We should get like the type size from the environment and a whole bunch of stuff, but we're not there yet. Sorade's like turning into the numbers, Mason. What do they mean? 2, 4.5, 7, 6. It's the oh man. They've got you in the chair. But yeah, it's basically just replacing the instruction with a store. So store from the register of the argument that we're being passed into the stack, and the stack allocate we just generate here, and then you just insert some instructions. We have the register instructions, so we can just move from a register, no questions asked. The result, the register allocator just goes, okay, yep, that's the register we have to move through, got it. If that makes sense. Anyways, that's all the lowering there is. x86-64, not too complicated. Mostly has to do with calling convention. In any case, oh, I also added a final printout. That way we do get some output of the register allocation that happened. I changed the white space and delimiters to include tab. I don't know why it did t/ instead of /t. I added /t, as you can see. But yeah, so I added tab as white space and a delimiter because I guess some people use those. Node returns value. Basically, this is in the parser, and if the node type returns a value, then it returns 1. This is important for the type checker, which got a little update as well. That's no longer to do, we do that. Sorry, it says 3986, 2616, 9112. Oh god, it really does seem like nonsense, lol. It does. If you were walking down the street muttering that to yourself, people would be scared. They would cross the street before you get to them. You know what I mean? They'd be like, oh man, there's Sir 8 again, mumbling his numbers. Better stay away. 39, 86, 26, 16, 91, 12. 39, 86, 26, 16, 99, 12. Terrific Table 55 says, hi, what's up, Terrific Table 55? How's it going? Can I call you Table? Would you prefer Terrific Table? Can I drop the 55? Four words is a lot. Terrific Table 55 says you can call me what you want. I'm gonna go with Table. Let's go Table. At least I can see Table. It's in bright red. It's good. We're almost at the end of the PR. Anyway, in the type checker, we ensure that the return value of an if expression is actually returning a value, which is when we use that. That's it. That's all we do. The type checker now enforces that. We should probably also enforce that a function returns a value, but I don't want to stomp on like void functions if we ever want those, so we're going to figure that out, aren't we, Table? But yeah, so we that's the PR. We're going to merge it. We did a merge. How about that? I probably could delete the branch, but it's fine. I'll delete it at some point. Ooh. Is this new? I've never seen it count up. This has to be new. Table says, I don't think I know enough to be able to help here. That's okay, I'll guide you. I'd never noticed that this counted upwards. Isn't this crazy? I feel like I'm in the Matrix. Like, this isn't supposed to be moving. I'm in Harry Potter and the pictures have started moving. Like, wait, that's not how that works. Oh, it jumped to 1 minute at like 40 seconds. Okay. There you go. It's live. Did you know that? All these numbers are live, updating. The fuck? I've honestly never seen that. I've never seen that before. That's cool, though. Anyway, we merged it. It's merged. Let's pull it. And let's figure out if we can pull it. Do I have to make another stash? The 15 millionth stash. I guess I have to go back to the main branch either way. Git is taking a while. That's the longest it's ever taken. I don't have to make a stash. We're good. Okay. We're gonna switch branches. I still need maggot. Branch, check out a branch revision main. Okay, we're now on origin main. There's an emoji there. And Emacs is like, we know what this is, but the font doesn't have it, dude. I'm proud of my font for not having emoji in it. In any case, okay, where are we at? I guess we just have to try and build it. That's where we're at. So we're gonna run a little build command down here. Not too complicated. We're gonna clean first, so we're gonna rebuild everything. Then we're just gonna assume that it works and run it. With an example, let's just do greatest common denominator. Perfect. Oh, and I closed it. That's good. Oh, and I closed it. That's good. There we go. It's the difference, the difference between Control-Z and Control-Alt-Z. Implicit declaration of function IR insert into block. Didn't we just go over how we added that? Oh, I didn't poll it, did I? I'm a smart man, you know? I do everything in order. I close maggot often. Because I mean to, you know? That's really what I mean to do. Is close maggot all the time. It's going well. It's going well. How are you all today? Thank you so much for tuning in, everybody. How are you all? I'm a mess, apparently. We're just gonna pull. Yeah, fetch from origin main. Go for it. Okay, that should help. Boink. Hey! That's what we want to see. That's a fail with code 1, because we asserted 0. How legendary. Oh no. Terrific Table says, I called you Terrific Table. Table says, I've recently found a really cool font on GitHub. Oh god. So it says most font don't have emoji. Usually editors, etc. insert actual images for them. What? Oh my god. I've had to typeset emojis in LaTeX before. Good thing I had my preprocessor, lol. Oh lord. No kidding. You can't be serious. Table. Oh no. If you can work with this, that's amazing. This would drive me crazy. I can deal with this in Lenser OS because it's a PSF2 font. We're gonna look up PSF2 font. Here, there's the OS dev link and the other link I used. Perfect. Where's the OS dev link go? It disappeared. There it is. I think we should be looking at PC screen font. Yeah. We use a PC screen font because the only thing you can specify is you can specify the height and width, but we don't actually have a way to specify in PSF1 the width. You can only specify the height. This is PSF2. Which means that with a PSF1 font, you have 8 pixels wide. Table says, I need the FPS. My PC can't handle more than 15 pixels per character. I've got bad news if you're using a TTF. What type of font are you using? The OTF? If you're using an OTF, then all these corners are much... I mean, they're harder to make into an image. I'm using the VS Code plugin, I think. Okay, then I don't know how that works. But if all these corners would be actually more points to handle in a text renderer, like for something like FreeType and HarfBuzz, this, I mean, it's just code is pretty easy for HarfBuzz. It's like the easiest thing. But yeah, there we go. We found it. PC screen fonts. There you go. Fun compiler. Merged its PR. How beautiful. And we are ready. It's working. You can look at this glorious, glorious, greatest common denominator program written in our language. Where is it? There we go. Oh, I can even load the editor. Ooh, editor. I wish I could, I probably can load file from anywhere, can't I? I gotta do that more often. I always forget. Okay. This is our little programming language, and this is our little IR associated with it. Table says, I think. Also, I'm kind of used to fonts like that since I do a lot of Minecraft modding stuff. Nice. Minecraft modding is like deobfuscation to the max. It's crazy how much they try and stop it. So, for example, what we're looking at here is the intermediate representation broken into functions, basic blocks, and instructions. Now, the intermediate representation instructions, for example, global address, would get the global address of lambda 0, which is R1. Well, this is label 0, but it's the first lambda, which is this lambda right here, which generates its own little label and has a name in the compiler internals, but it's unnamed in the program itself. And then that is, the global address of that is loaded into racks R1. We store the result of this wherever this has ended up, which is R1. So we store R1 into GCD Euclid, which is a global name, and that's how this assignment right here happens. How about that? We then load GCD Euclid back into racks. This is already there technically, but as you can tell, the global address and global load are different, so it'd be really hard for the compiler to understand when it would be okay to remove this. So we load the global address of GCD Euclid. We could probably say if we load right after a store the same address and the same global or local, then we could just remove it, but we're not there yet. Anyway, we load racks with the address of GCD Euclid, this global address, and then we load R3 and R4 with 88 and 32. We then copy those to R3 and R4. Don't worry about that. We'll just skip those because the result register is the same. So the backend will actually remove those. And then And then our last thing that we will do is call 3, which is our load of GCD Euclid. So we'll call this lambda right here, assigned to GCD Euclid variable, and with 6 and 7, which are our copied instructions into the proper registers. They're already in the proper registers, so no copy will happen, but that's where we get them from technically. Table says, I have written a Java obfuscator to obfuscate my mods. For some reason I do that. I don't actually need to because only I will ever be able to use the mods I make. I thought Java was obfuscated by default. King Bun says, lol. That's so good. I thought Java was obfuscated by default. King Buns coming in with the quick quips. Quick maths. Table says it kinda is, but you can just read the class files using bytecode viewer or recaf. Oh lord. Anyway, that's the main function. And that's this right here. Then you can see we have the actual GCD function, which is more complicated with a bunch of conditional branches because there's ifs. Hopefully everything here makes sense. Because if it doesn't, oh boy. But everything here should go well. You know? Should be okay. I hope. I don't know, but I hope. It looks correct. So now we're just gonna start listening to this assertion message and actually start coding. How about that? How about that? Ooh, I don't know how to say your name. Yanariel. I'm going with that. Followed 8 minutes ago. Thank you, Yanariel. I really got to get better at looking at that instead of just chat. Table says IntelliJ has an option to view Java class files, but only the bytecode. Crazy. Okay, where are we at? We're in CodeGen, and we're going to do the x86-64 backend today. At like line 1000. Yep, it's near the end. Hallelujah. Where are we at? Perfect. So we emit a function, and we just emit all of the blocks within it, and then we emit its return value. We emit all of the instructions in the block, and then we emit its branch. And then we emit all of the instructions, and this is where we're running into the to-do handle IR type 14. Let's do this. Can I do a print? What do we have? I think we have a print in... What do I want to print? The intermediate representation. Do I have print in here? We don't. It's femit, isn't it? That's what it is. So let's do a femit to standard error, I guess. Why not? And we want to femit a single instruction, which is instruction. This will probably give us a better, more human-readable name. And then this will give us the number. Let's try. Oh, don't Alt-Tab, just recompile. Perfect. So we can see that it's a global store. So we need to emit a global store instruction. Oh man. You know, easy. So let's check if we've done this before. Look at that. Okay, Twitch is just sabotaging me, giving me notifications that I, in fact, am live on my phone. Thanks, Twitch. I'm live, I know, because I'm live. I'm at my computer. It's like they expect me not to know. Hey, you're live. Like, it's been 30 minutes. I've been live for 30 minutes, and they send me a notification now. Jesus. I swear there's some dude just doing it, having fun with the button. Like, watch, I'm gonna get this guy. So good. So all we have to do is do this. We could even call this function, but I don't think we need to complicate things that much. I think we can just do this. Oh, yep, go up. Too far. Where am I? There we are. And give it context. Okay. Now, as far as source, what do we need? Okay, we have to look at what register to name. So this would be the register. So this is going to be instruction result. And then name is going to be the value name. So it says make sure to always check the order of operands because this is C, the compiler can't check that for you. What? Oh yeah, yeah, these. It should be good. I copied it exactly from the global store up above. I copied this and then renamed the operands. I didn't move them. I'm very purposeful on that. Because these are all variadic, I know. I can always check up here if I really need to. And go, okay, so first we need the, or it's this thing. Then we need these things. I think it's probably described somewhere, but... So it says, okay, good, because I've had a lot of seg faults and annoying bugs because of that. I mean, we're going to be recompiling after every single instruction, so we should be good. Could not find register with descriptor of 0. Okay, that's fair. So I probably just used instruction result when I shouldn't have. Oh yeah, because a global store doesn't have a result. So it's going to have a value. Here, let's turn on autocomplete if we can. Yeah, see, it's a global assignment. See, it even knows. Look, it knows. So we're going to move wherever the new value is stored into the global assignment name. That's better. Sure. Try that one out. The order is defined in the enum, if I remember correctly, as in there are comments there describing that. Legendary. I knew they were somewhere. Now we have to handle a global load. First, what I'm going to do is go open up the code we're generating and make sure that it's not insane. That actually looks correct. So if we look at what we're generating, it looks like the main function. We're not generating the entry point, which is a little worrying. There's just we're still in the data section. So to do generate the entry point, right there. In any case, the load effective address of R0 into racks seems like, yep, R1, this right here. And it looks correct. Everything there looks correct. We have .L0 and at totally the wrong place, it seems. And, you know, we're loading the address of the main function, which may be a bad thing. Sorry, Lamal. Yeah, just slap a Leah in the data section real quick. It'll work. It'll work. No, it won't. Okay, why are we not generating our entry point? So we say section data, and then we just IRF emit. Okay. Yeah, that would be an issue. Okay, where do we call it? Here, we call it emit function over and over. Jesus. To do generate function label. You think that might be important? Jesus. Okay, so we're going to need to do that, obviously, and block labels. Okay, so before we emit all of our functions, we'll just make an emit entry point. Why not? Do we already have one? I feel like we already have one. We do already have one. I'm gonna steal this then. Yoink. Because we're gonna get rid of all the codegen underscore functions is the idea. Still gonna need the context apparently. I mean, yeah. We should probably just have these take files eventually. But we may need the context for stuff. Do we need a function? Do we just need the context? I think that's it. Cool. So before we emit all the functions, let's emit the entry. Jesus. We could also probably, the entry function may not be the first one, so we'll just add a to-do. Add entry only on entry function, not just the first one. I think that's fine. Okay, let's try that out. That looks a little better. That looks a little better. Brilliant to do. Yeah. You know, big brain to-dos in this house. So we now have one global variable GCD Euclid, which is 8 bytes. Makes sense because it's a function pointer. Be cool to use a linker script and get away with like 1 byte addresses. I have such cursed ideas. Okay. Yeah. So we make some stack space. That's just generic stack space, so just in case, really, for the function, in case it overruns the stack or needs it. Ideally, this should include all local variables, or the size of all local variables in the function. Okay, now, why are we generating L0 here? Do we know why? That's one thing I'm curious about. Let's fix that first. Why is L0 happening? We have section data. So we're printing section data. That's it. That's all that's being printed there. I don't know why I did it like that. I think we can do this, and it'll be fine. Right? Yep, it's literally just a string. Okay. we have space. So it's before that. What's being printed before that? Oh no. We gotta go track something down, I guess. So from here, we should be being called from code gen. Sorry, it says probably an emit block emit entry. Yeah, that works. Don't know why I did it with %s lol. That was probably me. I do that because I'm scared of zero length printf warnings, or you know what I mean? I can't remember what the argument used to be in GCC, but they always used to give them. If you just gave printf a string, it's like use something else. It's just a string, dude. Da, 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 da. I don't see fprintf anywhere here. I'm just calling codegen emit. Ah, yeah. What? Okay. There you go. I love the strike through on Fopen, lol. Clangd cannot be convinced that I am to do remove this. Yes. I don't know why I didn't just remove it. Clangd cannot be convinced to not use the Microsoft libc. Like, even if you tell it explicitly not to. Like, here's another libc you can use. It's like, no, these are my system headers and I'm gonna keep them. It's so annoying. It's fine, but it's annoying. The strike through on Fopen, God. It's like, you can't do Fopen. What are you, old? Oh my. Okay. So, what are we getting in the assembly now? That looks a little better. L0 hasn't been used yet. That's ideal. Okay. So now, yeah. Now we just got to think about, yeah. More stuff to do. Handle IR type 13 global load. One of these. There we go. There might be a lot to do. So to load a global, I'm pretty sure we've already done that. Something like that. Did I pass it again? I'm bad at that. Okay, so we have context. We have a name, which is the global name. And in a global load, let's actually go check out how we generate that to see what that looks like. It looks like it just has a name. Yep, so we're just going to load into the instruction result and from its value name. Okay. There we go. We got a little further. Did we? Nope. Did I not put a break? I forgot a break. I was a bad boy, wasn't I? Yeah. We had a case run through. Why is it not telling me? Do I have pedantic off? Handle IR type 0. That's probably load immediate. We're just going to put that at the top because it's probably simple. Immediate. It's got to be somewhere. We have add. Okay. Where do we load a number? I can probably just write this by hand, but we got to use our fancy femit. So we want to move into a register, right? So we're going to do immediate to register. That's how this works, isn't it? Yeah. And then let's find an immediate to register move and copy it. Yeah, that would be ideal if we had one, like Dinkelberg. Team returner's dad or whatever. Okay, so then we move. Yep, here we go. So when we move an immediate to a register, we're looking for the instruction operand, which is I move. We pop that off and then pass on the args to immediate to register f-emit. And then, where is it? Okay, don't do that. Im to reg. So we need an immediate and a destination register. That's it. Okay, immediate destination register. So we need that last after our immediate. Okay, that doesn't seem too insane. Hopefully it works. Ruh-roh. It doesn't work. I messed it up. What did I mess up? We're missing something somewhere. So we have immediate to register in iMove. We were just there. So it's expecting the operands first. Yeah. So the operands is the first variadic instruction after the instruction. So this is like immediate to register. That's this thing. And then we call it with context instruction args. We go to immediate to register. And then we pop off immediate and destination register. It's as a register descriptor. I don't know what that is. It's just called register now. Maybe that's what our little issue is. Does this have to be 8 bytes? I wonder if I should change all of these. Well, we'll see if this works, and we're going to change all of them. Yeah, that also crashes. Back. What do you think is different? So which ones are working so far? I don't think we've done a move quite like this yet. Further up. There we go. So we did a move name to register, and that was fine. Be careful when passing numbers. I mean, it's should be the right thing. We'll see. I'll trust you, Siraid, but it didn't help. Rip. Do you think it's this? Which one do you think it is? It's neither. So we move immediate to register. f-emit x8664. Let's just find that. Yep. Yep. We might have... See, we don't have codegen immediate, which is quite odd. You think we'd have codegen immediate. But we don't. We have add immediate. Okay. It's not here. I don't know what to tell you. I thought that's what it was called as well. Figured just by searching immediate I would find it, but there's nothing. We have add immediate. We have, what was that? We have a function call type internal. What did I mess up? So immediate to register. So all we're expecting is the instruction. And then after that, it's all var args. And there should be 3 var args, right? Because we should have this one get popped. We pass it the next to immediate to reg. You have to emit a move. There is no load immediate. Yeah. Makes sense, I suppose. How do we emit that move is what I'm trying to do. So we're calling instruction mnemonic x8664 and register name. And what is, we don't know why it's crashing. It just says no. Sure. That's not gonna work. A classic exit 1 debugging. Hey, it worked. Huh. 16, you say? One, two, three, huh. This one. You would think, Sir8, you would think. You want to see what we got? It's pretty much that. Context, I move, immediate to register, immediate, register. That's what this is. Is it not? Am I dumb? Do I have an extra comma? No, it would tell me. I got nothing then. GDB/VS time? Ugh, I hate this. There needs to be a better debugger. I don't even want to put it on screen. We need to write a debugger. Sorry. I know the project that is going to be for both Lenser OS and other platforms. It's a debugger. I mean, CLion is a thing. A free debugger. GDB is not, I don't think it's up to modern standards. I think it's a terminal solution. If you only have access through SSH, use GDB. But there's just got to be something better, man. I can debug it in CLion if you'd like, lol. I mean, you know what to do. All you have to do is add this one case and then try and get it to work. Because we're basically on the main branch right now. All I did was add these, no? Okay. What do you want to... Also, I wish Rohan was here. We're exiting with code 5. Okay. fprintf is failing? What? Isn't that standard out? Oh my god. Where are we? Okay, not there. We're okay, we're failing to print to standard out. No, to context code. It's just not working. How? Racks. Rip. Error. Name is 1. Why is it doing name to reg? What? When? Where? How? Oh my god, no. No, no, no. Okay, we didn't need the debugger. I hate switch statements in C. I don't even know what buttons to hit, man. Okay, how much do you want to bet that works? Someone isn't compiling with warnings, I see. I mentioned that earlier. Why are they off? I'm gonna go turn them on. I literally mentioned that earlier. I'm like, why aren't the warnings on? Oh, I see. They're gone. They're just not here. You know, the classic. They're just gone. Should be enabled by wall extra. There you go. Target, compile, definitions, options. I always forget. Options. Func. Private. And then Wextra. Wall. You know what your build system should have, Sarade? You should have like a user-only script that gets called every time you run the build. So like you can add stuff like this into not the CMake lists itself, so you don't have to alter that, but you can have like a user script which alters it. That gets run after everything gets processed here. You know what I mean? Does that make any sense? That way, like stuff like this could be added on a per user basis. Sarade says options. Basically, yeah. Oh, that probably wasn't in response to this. Sarade says I can have it emit a target compile options. Well, that's what I'm saying. Like, you know, the build script in the custom build script programming language, the build programming language. Just have like an alternate, like it looks for .build user or .user build or something like that, and it'll load that basically as just append it to the original script. Just to allow for a user to basically, I don't know if that's the best way to do it. Okay, we have a ton of warnings. What do we got? Last expr set but not used. During parsing? Okay. Just comment it out, I guess. I think we used to do a check or something. This is during code gen, isn't it? Yeah, it is. It's really not a big deal right now. Because we already keep track of the last instruction. Yeah, we're fine. We're good. We can just get rid of those. I typically just disable unused function parameter. It does clean up the code. There's no reason not to go through and do it. Unused variable new branch. That's fair. Unused parameter info in build adjacency matrix. Interesting. Cool. I mean, I'm not one to deny a simpler call to a function. We could just void it to keep the function signatures identical, but I don't think it's really needed. Like, yeah, There's no reason to pass info, so why would we? I've got to clean some things up here. Okay. Same thing in build adjacency lists. There you go. Don't need it. No, somewhere here. Serrated has a single eyeball. We could just void it. Spoken like a true algol programmer. Change as little as possible. Okay, what is it telling us? Comparison of integer expressions of different signedness. Argument register count is a size t. So just cast it to like a, what is it, in 64t? Do we have integer t? Did we do that? No, we just did in 64t, didn't we? That's fine. There's more. Okay, close that. Coalesce. We also don't use info. Well, yeet it. I don't think, if we don't need it, we don't need it. Sorry, it says voiding is a term used in algo, you know. The safe way to do this is to check if it's less than 0 and only then cast it to size t. But most people don't do that, to be fair. See, I cast it the other way. I cast the unsigned number to the signed number. So I'd have to check if it's not that it's less than the proper amount, you know. Like half of whatever it is. Nick 1666 says, "Yo, what's up, Nick? How's it going?" Unknown conversion type character Z in format. Oh, in expansion of macro assert. Z? Well, that's a size T there, bud. It's not Z, it's ZU. You're confused. Nick says, haven't caught one of these in ages. There hasn't really been one in ages. Okay, if we continue and blast through all the unused, what do we got? Let's just dash W no. How do I do this? No unused, like this. Does that work? Do I have to do both? That works. Okay. Well, there's a lot of unused functions as well is the problem. It's complaining about assert and printf. I don't think it's a problem. It's doing, it's saying we don't know what Z is, but it's a ZU. It's fine. Everything's fine. We should be good. This is why I probably wasn't compiling with warnings, because there's a million. I probably turned them off because in the Arch backend, we have all the code gen functions and they're all unused. So it's just a million warnings. And a lot of them don't use the context that they're passed, so it's even worse. Where are we at? We are at a copy instruction. Womp. It's going to be a rather simple one, I would think. Register to register. And basically, let's just check out. It's going to be a move, not a lay. It's going to be like that. Okay. And value, this is where we're moving it from. What is value up here? What's type? It's a register descriptor, just making sure. So we want to move from the reference result, where whatever instruction we're copying the result from, into our result. That should be it. Oh. Break. Buffer OXAA55 says, hello, how's it going? Thank you for tuning in. We got Nick, we got Serraid, we got Buffer. We're doing good. Everybody's all here. I don't want to add these on top. Let's start adding on bottom. Case IR call. This is going to be a difficult one. Yeah, we know. I don't think we have to do this anymore. Oh boy. Yeah, I don't think we have to do that at all. So I just want to see how to use call. Indirect branch. Switch on operand. So it looks like the operand is either register or name. Again, is this up in the enum? It's not here. Here it is. Nice, it is. Call. Apparently nothing. Hopefully the same as this. So label or register. How's everybody doing? How's everybody doing? Okay. So to generate this call, we're calling a register. So we just f-emit a call to a register. That's all we have to do. All of the arguments have already been set in place, and all we have to do is emit the call itself. So it's not going to be complicated. All we have to do is emit a call. We can probably just rename this to f-emit. I don't think there's any reason it has to be x86-64. So it's an IR call, and it's going to be a register call if it's indirect. Okay, so this is when we have to do instruction value call type equals IR call type indirect. Call this register, please. And the register that you're going to be passed is the instruction value call. What is it? Probably call value callee result. Jesus. Okay. Else we're going to emit a call to a name. And we're going to do call dot value dot name. I think that works. Where it says, yeah, I just called it f-emit on my branch. Lol. Okay, so apparently that worked. Let's check out the code. So we have the data section, which has one global variable, the text section, which has a global main function, main. That's pretty good. It's working well. We push RBP, move RSP. We do this stuff. So we make stack space. We load the global address of L0 into RIP to be generated later on. GCD Euclid is loaded. We store 1 into GCD Euclid, yep, racks, which is what we just loaded into. We then load GCD Euclid into racks. Again, these are, this is extraneous, but it's fine. Is it a Yush says, yo, first time chat. What's going on? What's up, Is it a Yush? Thank you for tuning in. How's it going? Thanks for saying hi. Oh, Is it a Yush followed. Thank you so much for the follow. How's it going, Is it a Yush? So it says instruction value callee result with eyes. Listen, it's not that bad. The call has a value it's calling, and the value has one of two types, either a callee or a name. And then the callee has a register result that we need to access. So it says agreed. It's not that bad. We all know what it means. Is it a Yush says, had to literally log into another account to watch the stream, lol. Oh no. How come? The global assignment one a few lines up is worse. It's honest, it's better, technically. It's a union access of global assignment with just a member and stuff. The name is long, though. It's definitely longer. Still 72 characters wide, even with indentation. In terms of characters is what I meant. I see. You're right. That's the 72. That's the most. Okay, well, it's working. Everything seems to be going well. We load 88 and 32 into the proper registers, and then we call... Whoop, don't do that. And then we call racks, which we loaded with the function address. How beautiful. Okay. Let's keep going. What do we need to handle now? IR type 3, which is a return. That should be quite easy. Case IR return. Emit. Context. IRET. Isidiush says, is this assembly? We are writing in C right now. And when I go to check code.s, this file, this is assembly that the compiler is generating, which we are now writing the backend to generate the assembly from this intermediate representation. And we already did all of our register allocation previously. How about that? Suspicion. Sir Hade says, I love the call after the ret. Shush. That's what I just saw. I'm like, wait. I don't know why. If anybody knows why that's happening, let me know. Let's just try and let's recompile it. Yeah, it's still there. Fuck, man. We could think about that one. Nick says that call is sussy, kind of dubious. Insane streamer makes a dubious call in a compiler development. I can see the title now. Oh god. Sarade says, good to see that this would still be valid Fortran. 72 characters wide. Yes. Easy to use. Ahaha. Yes. Ahaha, indeed. I mean, we're breaking. I found it. Okay. It's got to be not this, but this. So the function return value, we don't actually need to emit a duplicate of. Beautiful. Okay. Yeah, we could just yeet that. Nick says, ah, whoa, no, nope. Both your names are green. I read it wrong. Nick says, well played, well played. Yes, yes. Okay, where are we? Why do I keep just skipping everything I need to do? Okay, now we need stack allocate. This one also, I don't think is going to be too complicated. I forgot the IR. We're basically just going to create a subtraction. Oh god. And this would be immediate to register is I think how we would frame this. And we're basically going to subtract. We want to subtract from the stack pointer. So let's go look at how sub works. Exactly like that. We've written this before. Okay, so as we can see, we would like to subtract, not that, right? We would like to subtract, also to do, have stack allocations be a no-op loop over instructions in function before generation and allocate all at once near the beginning. Not near the beginning, at the beginning. Perfect. Good enough for me. So immediate to register, there needs to be a number here. So we would like to subtract the instruction value immediate. We can cast to int64t just in case. Probably should everywhere we pass a number is cast it to the right thing, but yeah, it's fine. We'll be fine. I'll go check that that worked. Sub 8 RSP. It did work. So now the only reason this is getting a little weird is because we're not generating function labels or anything, but we're starting to generate the next function. Does a function have a name? See, we don't really store a name. We store an ID in the function. So let's just see what that turns out to be. Probably like this. Whoops, I'm doing well today. I got better on the keyboard, but worse than my brain. So it says, I'm almost done with the tests, and apparently an empty string is supposed to be a valid URI. Oh god. Isidayush says, guess I just really like watching things I don't understand. Feel free to ask any questions anytime. Right now, I'm working on generating a function label for this intermediate representation in the assembly so that when we actually are done doing this return and do a stack allocation and stuff, then we can clearly see it's in function 2. And also if we need to jump to function 2, we need to generate a label of some sort. What is the function ID? Type. Whoops. Yep, I'm good at this. I swear. The size t, so we can just %zu it to print it out to the code, followed by a colon. Let's see what pops out, shall we? Not that one, that one. There we go. Nearly. So where are we getting this L0 from? Why do we say L0 here? In our Leah. We're getting it from somewhere. Whoops. It's a global address load. Yeah, the global address of L0, which means it's just using name, which is a string, in the IR instruction itself. Oh man. What are we just looking at? Global address. Okay, so, oh boy. Why are we doing this? Why are we loading a global address? So we're loading a global address because we're at the beginning of a function and there's a lambda. Okay, so it is in the function where we just were. Node type function. So this is a lambda. Yep, bunch of stuff saying don't do this. Perfect. Yeah. So then we use result here, but we don't keep track of it anywhere. We call cogen function. What is cogen function? Where is that? It's got to be here. Yeah, so it's right down here. So we call this is result unused name. It's unused. Okay, that would be a problem. So we're just going to go to the intermediate representation. And we're going to develop, what are we going to do? To a function, we need to add a name. I don't think that's too insane. Functions have names. And they may be auto-generated by the compiler, but they do have names. Now in codegen.c, we'll have IR function enforce a name. That way we don't forget it again. Is that insane? I don't think that's insane. This can probably be const. Sarade would be proud. Function. IR function. So it's const pog. Yeah, we got a const cast. We did it. I guess I should wait till down here. We'll just put it here. It doesn't matter. Did I not make it const in the IR function itself? Funkitom. I didn't. Yeah, we don't want to change a function's name. I think that would be a good way to break things. Okay. Do function. Okay. Did it work? What happened? Error. Okay. Too few arguments to function IR function. IR function main. I mean, yeah? Did it work? I think it worked. Did it work? I think it worked. Well, it nearly did. What happened here? Oh, we're still not using the name. Okay. Okay. So now in the Arch backend, in emit function, we don't want to emit this bad boy. That's insane. We want to emit a name. What about a name plus a new line? And a colon. Gotta love those classic mistakes. Okay. Well, that's interesting. Something interesting has happened. Okay. We're gonna continue. We're gonna make this a little simpler. To do. Yeah, check emit entry. Yeah. Yeah. I could just use this here, but I think I'm just gonna move the fprintf here. We'll just use it. Why not? We'll move it up. I guess we could do entry to what function? I mean, there's main right here, right? You meant just don't call emit entry? Yeah, I think we're talking about the same thing. Also, how did I screw that up? I didn't copy and paste right. It emits the entry point for the entire program. Interesting. It does. So it should probably just not do that. You're right, you're right. It's not a function entry point. To do. Maybe make, whoops, Jesus. Maybe make some functions not global. Okay, we can just get rid of that. Beautifulness. Codegen prolog x64 emits entry point. Okay, we're just gonna go look at what that is. Okay, I'm comfortable with using these. We could just use leave and instead here, I think. But as far as where do we got? Yeah. So Sraid says leave sucks. Why? I mean, is it slower? That's why I didn't use it. Okay, I trust you then. I'm sure there's a reason. Where are we at? Emit function. Is that how that works? Dot global. Yeah. As far as I know, it's slow. At least it's generally not used unless the compiler is in debug mode, IRC. Crazy. Okay. So syscall is faster. And leave is slower. Enter and leave are slower. What about enter? Can we use enter? Okay. I think that's looking better. I mean, it's not ideal to have that as a global. But will it still compile? I mean, it won't. This shouldn't compile, honestly. This is a mess. This in particular. There we go. Okay. Data section. Main function. Beginning of another. Okay. I've never seen anyone use enter, lol. Interesting. We should use it. I'm pretty sure it's okay. Syscall also saves the return address in RCX and does some other stuff. Yeah, it's messy. It does speed things up though. I would love to have an implementation of syscalls in LensWare OS where we support that. Just so we can support both. Because all it is the syscall handler, right? Enter is very slow and compilers don't use it, but leave is fine. Compilers do use leave if they make a stack frame at all, at least GCC does, but if ESP is already equal to EBP, it's most efficient to just pop EBP. There you go. Okay. So we can use leave, but not enter. Interesting. Is this gonna freak out? Let's just see what happens. Yeah, it works. And then we have what? A.exe? So it's not gonna work because we're gonna call this and then everything's gonna shatter itself, but it did compile. So let's keep going. What do we need to handle? A register. That's a no-op. We'll put those at the top. We'll put simple and no-op at the top. We have a local store. Ooh, and that's starting to get complicated. Okay, so we would like to move from a register to memory. And we would like to store, I think it just uses pair, does it not? Yep, uses pair. So we're storing looks like the left-hand side is the thing we're storing into. So that would be car. And then this is going to be what? Do we want to store it into this result? Let's figure out what register to memory needs first. Register to memory. Cogen store local. Hey, look at that. Okay. Source and offset. So what is source and offset? Source is a register. Offset is the stack offset. Okay. Not sure how to get that. It's probably somewhere. So source, we're storing from, oh God, I'm starting to lose my voice already. So we want the right-hand side result stored into the left-hand side address, which is the offset of base pointer. Oh man. So where do I store the offset of base pointer? So what are we actually local storing? We are storing 11, a register. Let's just make sure. So when we print a local store, we do car cooter. So apparently the local is 11 in R4. That doesn't make any sense, does it? Am I reading this wrong? And set parent mark is correct. Car equals left-hand side, the first one given. Okay. So local, the first one given. Maybe I'm passing it in the wrong, what I'm calling this. I just gotta check now. I'm passing in the local next. In my branch, the offsets of locals are computed before emitting instructions. What does that mean? That's like, that could be any time from lexing all the way up to emitting instructions. You're storing 11 and 10, looks right to me. Well, that's the thing. When we print this, right? We're using the left-hand side and then the right-hand side. You see what I mean? So when we print the local store, we're seeing the left-hand side first. But when we create the local store, we're setting the left-hand side as the local that we're storing into. How does that compute? Storage says right before emitting instructions. Oh, okay. I see what you're saying. So in the Arch x86-64 backend, you'd basically loop over all of the instructions and all of the functions and then just keep track of the stack offset and assign them. Is that what you're saying? Storage says yes. RIP. That's gonna suck. Do you see how this is kind of... So the left side should be the local, and the right side should be the source. So we want to store from the right side into the left side, but this is backwards somehow. I don't know. I don't know. Okie doke. Well, where do you store it? Do you just add another thing? Is it stored in the stack allocation? I hate that company does this. Is it the stack allocation? So I probably can't store it anywhere here. I'd probably have to make a new member. Like local offset. No? That's gonna suck. Okay. Unless there's another way to do this. Could I store it in the instruction itself? So we're storing R4 into 10, whatever. We'll assume that's correct. I guess that could be in lower. Yeah, it's probably here. Probably setting something backwards? No? Yeah, see, they're backwards here. I found it. I knew they were backwards. Okay, that's gonna exit with code 1. Why? Local offset. Okay. I mean, we're pointing to a stack allocation. So I guess we could just have like a... Yeah, we're just gonna do it. IR instruction. Okay, where's the actual IR instruction? All the way down here. We're going to not add anything here. We're going to add a new value, actually. That's going to be much like this one. It's going to be a... What should I make it? IR stack allocation. Why not? And it's going to have a size. I think that's fine. And a... What else should we have? Offset. Just like that. Okay. Stack. Allocate. So we don't create them here. So we don't actually need to. Ignore all those to-dos. Let's see. Could a result... So instead of doing this, it's going to be... Okay, I need to actually add it to our value. That's right. So this is going to be our stack allocation. Sure. Sure. Okay. And then that's not a number. We need offset. Make sure to cast it to the proper thing. And that should be good. We should be good to go. Now we just have to, you know, calculate the offsets. Storid says, I see you have the offset now. Oh yeah, we have the place to put it, for sure. Okay. So we have to do it after lowering stack offsets. We're just gonna do this. Okay. Yep, sure. Could probably get rid of that assert for everything in the IR. Why would we return anything? Implicit int, of course. Okay, so we don't care about parameter references, we care about stack allocations. And in each function, we're going to need an offset, which is going to equal 0 at first, right? Hopefully. Yeah, Yeah, should be fine. And instead of doing all this crazy nonsense, for a stack allocation function, we'd like to say offset plus equals, RIP by the way, offset plus equals instruction value, stack allocation, size. But before we do that, we would like to say that the instruction's offset is equal to offset. That's it, right? Is that insane? I think that's how that'll work. Every new function will get a 0 offset, and every instruction that's a stack allocation will add to the offset after recording its own. Okay. That was less complicated than I pictured. Now we just have to call this. Do not mess with the order of these. You will break things. Okay. Sorade says pretty simple, actually. It's very simple. I was surprised. I'm like, oh, we just record the offset, do it. Having this, yeah, it's nice. Boom, done. Boom, eyes. Okay, where are we at? So now that we calculate stack offsets, that's after we do everything, right? Yep, then we're just generating stuff. Do we want to do that after register allocation? That may be a good idea, just in case. Yeah, we're going to do that there. Why not? Yeah. Okay. Now we can't set the immediate. We have to set the stack allocation size. Okay. So now when we store into a local, we use the offset from base pointer. We may eventually want to ensure if we want to access other scopes, we may want to like bump up base pointer. We could always push and pop it, I guess. Be a little messy though. Let's see what breaks. Do you think it worked? I don't think that's insane. Does this work? Don't we need a 0 here? I guess I can just... I mean, it compiles. I guess you don't need a 0 there. Okay, we're fine. Everything's fine. So, if the offset is 0, move stack pointer into base pointer, sub 32 up the stack pointer. I guess we can also keep track of a function's stack allocations now, right? So when we emit the function, I guess we don't even need to do it there. When we have the function offset. You explicitly made it so it doesn't emit the offset if it's 0. What do you mean? I don't remember. I just wanted to make sure it's fine. It's fine. Everything's fine. Function local size. Should we just do that? I don't really want to add that here, but I don't know where else to add it. So we're just going to do it. Or we could remove each stack allocation as we get to it, but that would make for a whole bunch of messy nightmare fuel. So let's just add a thing to the IR function. Why not? And we're just going to give it a... oh, that's a block. I'm a genius. Okay, we're just going to give it a... I'm a genius. Used by certain backends. Probably should make this generic at some point. Locals offset. Locals total size, sure. I think that's fine. And then, ideally, we would just subtract that all at the beginning. And a stack allocation would no longer have to really do anything, right? Because when we emit a function, when we codegen prolog, so we use the codegen context. So can we just pass in that? I think that's fine. Do the cast for us. Yeah. So when we cogen the entry point, we don't use this, do we? We have emit entry now. We can just get rid of that, I believe. What do we use now? Yeah, okay. We can hope. So now at the beginning, you can see we sub 16, and then we sub 8 twice. Did I break something? I never got rid of the stack allocate, did I? Yeah. Whoops. Okay. Is this fine? So now sub-0 RSP. Might want to fix that. It's going to be fine, but definitely can remove that. Okay, what do we got? We have a main in which we push RSP sub-0, do things. We have a function in which we subtract 16, and then we're accessing upwards off the base pointer, so I presume that would... Why are we doing that? These should be negative then. So local store. So their offset, we're just gonna have it be negative. How about that? Is this correct? I think their offset should be set after. It should be set and record, shouldn't it? Because the offset stores the lowest address on the stack. Yeah, I think that's better. Because this would actually... Yeah, so it says I think so? Yeah, because when we sub 16, the stack pointer's now at the bottom of 16 bytes that we have access to. So when we want to move 8 bytes, we can't move 8 bytes into the top, aka the base pointer. We have to move 8 bytes down 8 bytes from the base pointer. When in doubt, just check it on Compiler Explorer or something. Nah, we got this. Nah, fam, we good. No, we should though. If I wanted to be correct and get the fastest answer, that's what I'd do. So we have a local store, and immediately after, a local load. Some dude has to wipe them down. Okay, so when we load, it's going to be a memory to register, right? Oh Christ, what was that? Just a loud sound. Sound like a bang. I'm going to copy this one. we are using context, base pointer, offset, and target. So our offset, we're loading into a local, right? So it just has a reference. So this should probably be, whoops. This is the local. And that's its offset. I don't know. And then target, where are we moving it to? Instruction result, right? I think that's right. That looks correct. Beautiful stuff. Beautiful stuff. Okay, handle IR type 16 equals. That's right. It's all flooding back. Oh man. Okay. Instruction. Comparison type. Left-hand side. Right-hand side. Okay. And then what? And then the result. Whew. Okay, there we go. That should be what we need, as long as cogen comparison works. Which it should. Yeah, hopefully. If not, it's going to get real complicated here real soon. Did I not break? Classic. Zero out RCX. Compare RAX with RBX. Set ECL. Yep. Okay. It worked. IO type 5, branch conditional. That's going to be fun. We have to deal with branch conditional before branch. Pretty funny. Okay. So the conditional has already happened. Branch if 0. That's got to be it. And then we just write branch to, we have register descriptor. Let's go check out branch if 0. Test, register against itself, and then jump if it's 0 to label. Okay. So this would be, whoops. Conditional branch condition instruction result. What we just generated here. Whoops. And then we end up with the label that we would like to jump to. Is this right? So branch if 0. We'd like to branch to the false branch if it's 0, right? How do we know the label of this, by the way? Do we have to label all the basic blocks? Is that something we have to do? It's gonna suck. Yeah, it's a number. We're gonna have to label all the basic blocks. Okay, so we need a label here. Am I doing this wrong? This is how it works, right? There's no like cogen. Here, let's just look up branch. We have branch and branch if 0, yeah. So this is probably the right thing to do. Branch if 0 to the else, otherwise just fall through. I guess we can't fall through, otherwise jump to the true basic block with a cogen branch. So what is branch if 0 really? I'm just going to take these when they're simple enough. Okay, so register is going to be our instruction value, conditional branch, condition, result. Perfect. Now we just have to figure out our label. Yeah, let's label our basic blocks. Why not? So, what do you what do you know? We foresaw this. So we're just gonna add a label to the block. I know that's probably not the best thing to do, but whatevs. We're just gonna say name or label. It really doesn't matter. And what we're gonna do is say if not block name equals, let's see, how do I do this? I guess I could just do generate label, right? How do I do this? Label generate. Got it backwards. By the way, how are you handling div because it clobbers RDX? Yeah, we're not there yet. Don't worry about it. I know. Where is label generate? Why do we not have access to it? It's a static in codegen.c, okay? Don't be that. We should probably just do it at a different place instead of doing that then. So what if when we're generating a basic block, so when we create an IR block, we could have it, give it a name? I don't know. We still need to make it public. It doesn't really matter. Do we have access to it now? Still gonna say no. We have cogen.h. You lying to me? It was. It was lying to me. Okay, so if the block doesn't have a name, we give it a name, and then we say use the name. And we're just gonna say blup 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 blup. And then when we want to reference it, we can just use the block name. So we would like to branch if 0 to the false branch name. Otherwise, we would like to branch unconditional. How do I branch unconditionally? Christ. Oh my Christ, this is such a hard word to type. Which one of these means jump all the time? I jump. What do we have? Oh, IJCC. Okay. What does I jump need though? A type. Name. Okay. Should be good to go. Should be good to go. Okay, let's take a look. See, we're now labeling the basic blocks. Huh? Yeah, everything looks great. Everything looks good to go. No issues whatsoever. Yeah, everything's great. Shh. Don't tell them, Saraid. They won't know. God damn it. I'm gonna drink some water. Hmm. Okay. I get why. It's because we haven't generated these blocks yet. We're jumping to a future block, which is kind of how it always works. So this has to go elsewhere. Yeah, we're just gonna do this. Guess what? It's going right here, baby. If block doesn't have a name, give it one. Okay. Label generate uses a static buffer, IRC. Yeah, it's not gonna go well. To do. Keep allocate or something. Ugh. We'll get there. Until it breaks, we'll just keep going. Uh-huh. Because, I mean, we'd need to generate like 1,000 blocks for it to actually break. Because it's kind of rolling. You know what I mean? It only overwrites once it completely loops the buffer, the static buffer. So we need like 1,000 labels, or at least yeah, they're only like length 3, length 4. They're probably length 4 most of the time, length 4 or 5. You could also just give each block a number. But then we'd have to generate these strings to print out. And we'd have to like either stack allocate or heap allocate strings in the CodeGen backend just to print things out to the file. And it would be awful. We could still just use a static buffer, I guess. Like a buffer of length 20. And then just write it with the label that's currently, you know, the number. But this is fine. We could also have a static, yeah, a static buffer where we write the block ID as a string to, and then use that as a label all around. See, this is why SSO strings are nice. It's true. It's not like C will ever have that, sadly. So now we need a branch instruction. Okay. And for a branch, it's going to be quite simple. Just jump to name. But it's not going to be a conditional branch. It's going to be block. That's it. Okay. Legendary. Sorry, it says standard to string in C++. Doesn't help doesn't heap allocate unless it's a float or double. Yikes. I don't even want to think about how that works. Let's just go look at subtract. Yeah, not too difficult. So this is basically just going to be instruction, pair, footer, result, and car. Hopefully that's in the right order. Handle IR type 6. That looks like a phi instruction. That's a no op. Hey, look. Oh, we did it. We did it, chat. Pog. Sorry, it says because if a double has like 30 decimal places or something, then it has to heap allocate because an SSO string, in Lens or OS at least, can only fit 23 chars. Sorry, it says Pog. Yeah, it worked. Okay. Little. We should say if we're jumping to the next block, we can remove it, right? We should do stuff like that. To do. If jumping to next block, don't generate. I guess we can just do that really easily, can't we? Because we have next here. So if this, it's a DAG, so if this equals this, don't do it. We'll just do that. You know what? We won't worry about that right now. It's fine. It works. Does everything here actually make sense? Why can I not do this anymore? Okay. I think everything here makes sense. We're going to try it. We're going to try it. So we're going to run GCC. And then we're going to run a.exe. Uh-oh. It didn't work. Okay. So it should return 8 or 16 or something. And it returned 253. Push arbaba, move ruspa sub-0 RSP, Leah, L0 rip, racks. Are you using shifts or div? No. Because those instructions clobber registers. I don't think so. I'm pretty sure we would have had to just handle it, and we didn't write a handler for it. Unless you remember something I don't from the last hour. Function calls clobber caller saved registers. True, maybe that's what's going on. Maybe a recursive call is breaking things. So let's do it. I think all we have to do for that is keep track of the... We basically just need a list of the registers used for each function, right? And then we just say if those registers also happen to be caller saved, then we have to save them. Does that make sense? I think that makes sense. because we already have all the registers allocated. You need to push pop all registers that live at the call site, that are live at the call site. I mean, there's no really easy way to do that though. And that's not true because the function itself should save some stuff as well, right? Yeah, we'll just keep track of the functions used in a function. Yeah, the registers used in a function. We're gonna have to loop over everything, I'm pretty sure. We'll just do void track registers or something. Keep track of what registers are used in each function. Sure. So it says excluding registers used to hold the function arguments whose liveness ranges end at the call. All caller saved registers, of course. Yeah. Yeah, we got it. We're fine. So how are we going to store the registers used? Right? I kind of vote for just adding a list here. So it says bit mask, I'd say. But that means I'd need like to add an int max t, right? I don't really want to do that. Registers in use. That's going to be huge, isn't it? It's going to be like 128 byte struct. 32 bits should be enough. I'll go with 64. We'll go with 64. Why not? You only have like 16 registers. In the current backend, yes. But if we want to support like Arch or MIPS, don't they have like 40 registers? Like R0 through 30 something? Either way, those 4 extra bytes don't matter at all. True. Info. Okay, so here we're just going to do the classic loop. Loop overall. Can I find a classic loop? We just did one. Right down here, no? The loop. Okay. So for every function, we want to say create an instruction list for it, or a register list, which is going to be whatever this thing is. Mask. And then for every instruction, we're going to say if instruction result, and I guess it doesn't really matter if instruction result, does it? But we're going to say register mask or equals we want to shift 1 left by instruction result. Right? We could do -1 if we wanted to save space. We'll just do that. Why not? Oh, I didn't add the case. We don't need a case, that's why I'm confused. And then, at the end of the function, we're going to say function. What's going to be here? That's right, registers in use equals register mask. I guess I could just use this. I don't need to even like cache it. Yeah. There we go. Those registers are in use in that function. Does that make sense? I guess so. So now that we track registers, we're going to need to do stuff. Just make sure it doesn't like crash on us. It still works. Okay. So now with these registers, what are we going to need to do? So anytime we make a call, we're going to have to say I'm not even going to read it, Sarade. I'm not even going to read it. I can't. So every time we make a call, we would like to first make sure that what? We push all of the caller saved registers that are used in the callee function, right? If we're just calling a name, then we can't really do much about that, can we? Because we don't know. So we'd have to push them all. To do push all caller saved registers when calling external function. Right? There's not really much else we could do about that. And then push caller saved registers. Whoops. What just happened? Used in called function. Right? Okay, so we're going to say we need some way to loop over all of the caller saved registers, right? It's going to be a mess. Anybody know of a good way to do that? Loop over all of the caller saved registers. So we're going to just need something like this. Yeah, it's basically going to be, okay, hold on. Put them in an array. Yeah, that's, that's what I've discovered. I was just hoping it would be easier. Than that. Caller saved. Is caller saved register dependent on... it's dependent on some bullshit, isn't it? It is. So we're gonna have to put it in the... do the same thing as everything else. With this whole mess. Is this right? I'm gonna look up, if I can, caller saved registers. And then let's do Microsoft. Yep, and then Linux, caller saved registers. Okay. What do we got? What do we got? So for Microsoft, looks like we've got MSDN. Where are we at? Calling convention defaults. These registers, blah, are considered volatile. Here we go. Okay, these are all the ones that are volatile. We're just going to copy those literally and then count them. Well, I'll get most of them. Whoops, no I won't. Whoops, okay, that was crazy. And how many are there? 1, 2, 3, 4, 5, 6, 7. This is MS Win. Ah, this is gonna suck. Okay. Okay. Sraid says RBX for Linux, RBX, RSP, RBP, which I think we already handle, and R12 are callee saved. The rest are caller saved. Oh, you're saying the... Okay, yeah. I should have read it through. You're right. I saw the list and I got excited. So we have racks. We have... You didn't mention CX or DX. R8, 9, 10, 11, 12 through 15 are callee saved. Is it the same? Are they actually the same? Racks, CX, DX. No, DI and SI. Yeah. Okay. Saraid said it. Yep. Yep. Destination. We'll do source and destination. Whoops. 9, please. Okay. Caller saved register count. So the caller, if they want these to be preserved through a function call, must save these. Okay. Is this going to be, yeah, a pointer? How did I do it with the other one? Yeah, a pointer. Caller saved registers. Caller saved register count. Did I even do that? I did. Okay. And then we're going to have to set these up somewhere. Oh, Lord, this is a mess. Okay. Caller saved registers equals mswin. Caller saved registers. Caller saved register count. Oops, mswin. Caller saved register count. What's the issue? Why are you mad? What did I screw up? Oh, it's a register. Of course it is. Sure. Linux. Okay. We now have caller saved registers. Okay. Right? Yeah. Makes sense. Now we just need to write, bear with me here, something to say, is caller saved? And then just take in a register, right? And all we have to say is, how do we do this? For caller saved register count, we're going to have to do something like this, aren't we? We'll do I equals 0. If color saved registers at I equals R, return 1. Lord. Okay. The count should probably be a size T, not a register pointer, just saying. Sir saw it coming. He knew what was going on. Took me a while to find it. If I looked at chat, I would have known. Okay, so now we have isCaller saved. Perfect. And now, yeah, ain't this gonna be dandy? Yes, it is. Yes, it is. IR call. Okay. 4. So we're going to loop through all of the caller saved registers, right? We're going to have to do that. I guess we don't have to do that. No, we have to loop through all of the registers in the function. How do we do that? So I have to go through each bit. Okay, this is going to be craziness. Yeah. I know I could just do that manually. Don't at me. So what if I did size of? Can I do instruction, block, function? Does that work? Is that an invalid size of? Suspicious size of by size of multiplication. I just want to get the bits. Times char bit. Okay. Size of char equals 1. Oh, that's a good point. Okay. Plus plus I. Okay. If. Okay, we're just going to have this copied. It's going to equal this crazy thing here. Yeah. If funcregs and I to the left, no, some 1 to the left I should also start at 1. So this means that it's used in the called function, but it may not be a caller saved register. Okay. Now we need to push. Okay, how do I need to go find a push? I. Is that insanity? It looks like insanity, but I think it makes sense. For every bit in the function registers, if it's set and it's caller saved, we should probably do these in the opposite order, but it doesn't matter. Then push the register I. And we should make like a linked list to pop when we're done. Should we not? Shouldn't we have a linked list? That way we can just loop over the linked list and iterate over it. You can also just keep shifting the bit mask to the right and stop if it's 0. What do you mean stop if it's 0? There can be gaps. No need for a linked list. Just iterate over the bit mask in reverse. Oh, I see what you're saying. I thought you were saying like if this is 0. I was like, there can be gaps in it. What? Yeah, I guess so. I don't like it. It's 2 loops. It's fine though. Yeah. Do I have to do -1 here? Does that make sense? Am I good? I think I have to do -1, do I not? Because this is going to be like, I is an index, whereas this is a count, a byte count. Yeah, we're going to need -1, because before we did less than. Sorry, it says -1, I think, yeah. Yeah, that makes sense, because I would never be equal to this if it's less than. So I should never be equal to this. It should be equal to it -1, all the way to 0. I'm going to make it an int. Why not? And then we're just going to say I is greater than 0. That way we catch underflows and stuff. 2 loops are still infinitely better than 10 heap allocations for a linked list. Okay, hear me out. We know the size of the linked list in advance, do we not? We don't, but we could easily get it, right? Which means we could allocate. It just means we could allocate like 8 linked list nodes in a row, right? That way it'd be in the cache. I'm just saying it's doable. So it says with a pop count, yeah. So there's an instruction for that. We're going to call this save and restore instead of push and pop, just in case somebody doesn't know the terminology. There's an instruction for that. Okay, I'm clicking a link. This instruction calculates the number of bits set to 1 in the second operand and returns the count in the first operand. That's incredible. I did not know there's an instruction for that. And there's intrinsics, apparently, that you can use with it. Okay. Okay. Cool. I did not know that was a thing. So we could very easily get that pop count. Look at that. That's funny. It sounds like it's made for exactly this purpose. A pop count. Okay. Roll up. So this is going to be for, I don't really care what it is. It's going to be less than caller saved register count plus I. Then we just need to do this thing. But it's going to be add I. Perfect. You know, you can just put the loops outside the if. But they're different. What? Failed with code 5. Classic. You need to push pop in either case. Differently, but yeah. In this one, we only want to save, they're different loops. We're looping over caller saved registers, all caller saved registers, or we're looping over the caller the registers used in the called function, and then saying if it's caller saved, save it. Why are they different? Because an external function, we don't know what registers it uses, so we just assume it uses all of them. Why would you save caller saved registers that are not used? How would I know what registers are used in an external function, Sir Aid? You want me to just go into the printf implementation, disassemble it, and then figure it out? Like, what do you want from me? It's an external symbol. I'm not doing it. I'm not doing it, Sir Aid. Jeez. You just want to not... You want me to magically have that information? Like, oh yeah, this external function printf, it's just a symbol, that's all we have, but let's magically know all of the registers that it uses and only save those ones. What are you talking about? Whatever registers the external function uses. So we're checking the wrong function, but why would we need to save them? So we need to, okay. Sir, I do understand. I'm just coming at it from a different perspective. Don't say that stuff. Listen, please. What we are doing right now is checking if the function that we are calling uses a caller saved register, save it. What you are saying is that we also need to check if the function we are calling from uses it, because there's no point to save a caller saved register if the caller doesn't use it. Just like there's no reason to save it if the function calling it doesn't use it. So yes, you are correct. We do need to alter both of these loops to check that this function actually uses the caller saved register. They're still different loops. Thank you for telling me I don't understand what I clearly do. But I do understand what I'm talking about. I don't just go, oh, why do I have these things? They're silly. I guess I'll just save them all. Good for you, Sir Aid. I'm glad you would do that. Jesus Christ. I would only check the caller, not the callee, honestly. Otherwise, that's a bit of a headache. You're a bit of a headache right now, bud. You're like, oh yeah, all that code you just wrote, you don't understand anything, and you're wrong. Like, come on. Come on, bud. What, you're not trying to see my perspective at all. I'm trying to see yours, and I see yours. You're saying, hey, you should check that they're actually used in the calling function. The caller, not just the callee. Right? I get that. I can add a to-do. Like, it's just another optimization, right? Okay, so to-do, only save caller saved registers that are used in the caller as well. Look at that. That's it. That was that suggestion. The thing is, I don't think this works because you'd have to check every callee of the callee recursively and so on. What? So you're doing basically the opposite of how it's usually done. Okay, let's change it. Fuck it. Who cares? Yeah. Here, we'll leave the comments for us. There we go. Cool. Yeah, we'll rewrite them. Okay, so what we need to check is apparently in caller function, according to Sir Aid. So we're going to go int I equals 0. Why not? So I guess we just need to loop over the ones in, yeah. Yep, all the bits in the caller function. size of... Here, we're still going to need func regs. I'm just going to do 8. So for every bit, and then if is caller saved, I, right? This is our current function. At some point, we could have indirect external calls and vice versa. Why? Why? How would that happen? You'd have to load an external... How would that work? You'd have to load an external function into... into what? It's always going to be external and indirect. Or external and direct, because you're just calling the name. So for every one, if is caller saved, and then push it. Is that your magical incantation that you would like? Oh, fuck you. This stupid fucking error. Yeah, this is so helpful to not be able to have anything declared in a switch statement. Then we just exit with code 5. Wonderful. Wonderful. We need to decrement. Doesn't help. Wonderful. So it says pop not push in the second loop. Sarade says the problem is not that you can't have a declaration in a switch, it's that you can't have a decal after a label. Well, and a case label is still a label. I don't care. Honestly don't care why it happens. It's just annoying. It's something that happens all the time to everyone who writes C. In a switch case, you want to declare a variable, and it's like, no. And then you have to do stupid shit like this. It doesn't even do anything. It gets optimized out. retarded. Like, oh yeah, we'll do something that is a no-op. That way we can actually write code. It's so dumb. Putting a semicolon after the label also works, or literally anything that isn't a decal. That's so stupid. Just stupid. Why can't you jump to a declaration? What's the issue? Were you supposed to just, no. Don't declare after a label. Do something else. Like, why? It doesn't make any sense. You can't just jump and go declare something and then jump back. It seems pretty doable. It's probably some go-to garbage. Why is this not working? Call instruction null block. Block null function. Ugh. It worked. I didn't change anything. But now we say block function does not exist. Oh. It's gotta be one of these then. All of these will have the same. Yeah. Uh-huh. What's the current function? Do we know the current function yet? We have to. Should be in the context. Yeah, but here's the problem. We have not the codegen context. We have the codegen context. Okay, it's just CG context. Okay. Yeah? Block has no function. Of course it does. I mean, we're calling attach on these. So either way, these should be set. And that's all we got. Okay. Wonderful. So it's not in codegen. The only IR blocks created are right here. So when we attach a function, we could say, I mean, we already do IR block attached to function, which says block equals function. Is context function not being set? It's being set. Well, I've got nothing. We attach the then otherwise, so they should already be being set here. Because IR block attach calls IR block attached function, which calls new block function equals function. So it's not the if, but a block has a null function. So it's probably the register allocation when we create a block here. Why don't we attach? Okie doke. See, we're not creating a new block here. We're creating a new block in the list. All the blocks aren't being created there. Where do we create a block? Here. Okay. Probably just get rid of that. So we still call attach to function on this. On what? On instruction block function. What's the instruction? The instruction's a phi instruction. Block has null function. Which block? BB1. The first basic block, right? Okay. The first basic block doesn't point to its function. So how do we initialize when we create a new top level? Oh God, this is messy. This isn't how this has to work anymore, is it? Where are these implemented? Yep, it is. You think grep would be smart enough to know that nobody uses it except for recursively. They gotta go and make whole other tools for that for no reason. Okie doke. Do we have like an initial block set here? No. So block would just still be null. That's what it's looking like. Okay. Well, I don't know where this block is even coming from. take a look at IR function. That's probably it. So we create a new block function is equal to function. Oh Lord, we did it. Jesus Christ. Does it work? Tweet. Yeah, we're using R8. Well, it still fails horribly, so that's good. That's going to be an issue. We can't push and pop racks. Is that the second one? Still wrong. So when we track registers, maybe also a good idea to track argument count. Hey, what's up? First time chat from Angry Kappa. Provode is raiding with a party of 38. How's it going, everybody? Welcome. Welcome, welcome. We are working on our compiler backend, trying to get it to work, because it's currently generating assembly that does not function as it should. How is everybody doing? Thank you so much, Grendius, for the follow. What's up? Ged Yuko with another first time chat. What's up? How's it going, everybody? Welcome, welcome. Hey, Provode and Grendius. How's it going? Thank you so much, Provode. I appreciate the raid. Provode says, what is the compiler for? Fun. I made a language. I made up a language. It's for this. It's still scuffed. It's still a work in progress. But it's for this language. And it generates currently x86-64 assembly that is very broken, that we're trying to fix. How about that? Okay. Yeah, any questions? I am down to answer them. We're just working on debugging some assembly right now and figuring out why it doesn't work. Why do we move RDX and RD8 and R8 here? How does that make sense? Provode says, cool. Is there a specific domain or idea for the language? Nope. Not at all. Just making it. So we should be moving RCX or RDX and RCX, right? Argument registers. So it should be an RCX and RDX. So what's going on there? So it says, all right, how are we progressing? Not at all. Caller saved registers thing works. So it's got to be in register allocation. So for every argument index, assign a copy. I mean, that's going well because we can see R3 and R4 are there. Wait, what's going on? Why are the functions gone? What is this? Where are we emitting basic blocks from? Hello? Oh, it's right there. More debugging. Okay, so we have R5 and R4. Beautiful, beautiful. So we have register R4, which is stored in R4, and then we have a store from 1011, which are these two. And that's somehow turning into the wrong thing. Move RDX and R8. So when we have a local store, are these backwards, I guess? I don't think they're backwards. Let's just IR emit instruction to standard error, and it's just going to be instruction. What is this? Local store 10 and 11, 13 and 14. Okay. Print me value pair coder result. I mean, that's R4 and that's R5. Why are they in R4 and R5? Are they one off? It's like it's one off. There's an off by one. It's always an off by one error, isn't it? How could this even be working? Okay. I'm so confused. Okay. What? Okay, whatever. So we have a local store, and the local store, the issue with it is, okay, yes. We're trying to move RDX and R8, but these are supposed to be our parameters, which should be passed. It's literally one off. See, they should be passed. Where is it? In these. But they should be here and here, but they're here and here. So when we access MSWin argument registers, here, do we have to -1? Why would that make any sense? I mean, we didn't crash, so presumably it's correct. What? Oh, I'm in the different place. I was like, wait, what? Okay, it's correct now. Okay, it's still not working. Yep, regenerate it. Okay, what do we got? Push CX DX, call racks, pop DX DX. Yeah, we should probably check that they aren't arguments only, but oh, whatever, it doesn't matter. That just has to do with like arguments in use type of thing. So we'll just have to keep track of argument count in the function itself. Load them into BX and racks. XOR RCX CX racks BX test CX CX. Jump if 0 to L4. Jump to L4. Well, that's incorrect. Is there a jump that's incorrect? Yep. That'll help. To actually jump to the right place. Jump to L3. We're nearer. We're nearer. Okay. So it's just failing with code 5 now, which usually means a bad pointer. So at the end, we move RCX racks. That's what we do in L7. L8 just returns. So let's say we move. What are we doing here? Yeah, we're just accessing the stack locals that we saved. So we save, in this case, here we can even look at the code. And you can see that if A equals B, A. So here's if A equals B. Here's the then, which we jump to, which is just return A into racks and then jump to L8, which just returns racks from the function. So we should be able to return A. Otherwise, we jump to L4, which means A does not equal B, which means that we save off of the stack A and B. We XOR RBX, racks and RCX are compared, A and B. Set if less than BL, test BX, BX. Jump if 0 to L6. So if A is less than B, we jump to L6. In which case we would load GCD Euclid into racks. These into DX and CX, the parameters off the stack, A and B. We'd sub RCX, RDX. A minus B, does that make sense? Or, I think that makes sense. Which one is stored here? -8. We have RCX, so the first, so A. So we have A, which is passed as -8 RBP. Then we say, okay, subtract. Which order is subtract in? I never remember. I think it's subtract CX from DX. So this would be RDX minus RCX, right? In which case that would be this one. Which doesn't make sense because we should be doing the true first. In any case, I guess that's the false branch, L6. The true is L5. Okay, so we're in the false branch, which means we're here. So we do A minus B, hopefully. And then we move that into our dx. So we use our dx here to store A. And then we use our dx here to store B. And cx ends up with this in it. Is that correct? Again, the order of the sub instruction will always eternally screw with me. Let's just see what we got. Bright warning. Whee! Sub. Oh, Christ. Seriously. So subtract the right side from the left side, but this is intel. So swapping that, we would subtract the right side, the left side from the right side. So subtract our cx from our dx. So is this backwards? If a is less than b, no, a minus b, we want to, yeah, these are backwards. Subtract is backwards, right? I guess. Oh man. Well, I guess we have to run it now. Okay, major issues, so that worked well. So when we generate a sub instruction, it sure is a confusing one, ain't it? So rdx, rcx, subtract our dx, a. See, that's backwards. The backend knows that it's backwards in AT&T and reverses it accordingly. Okay. Because this is backwards, right? Because we're loading B and subtracting A from it. That doesn't make any sense, right? -8 RBP is A, the first, right? Yeah, because we need to have the result interesting. It's like the result of the sub instruction is in the wrong place. Sub BA is A minus B in AT&T. Yep. So subtract. See, this would subtract A from B, but we have the opposite. So it was right. Right? Am I wrong? The problem is that it's ending up in dx and not being moved to its output. So we need to say if instruction result does not equal, okay, which one is this? So this would leave dx. This thing? Right? Is that correct? Oh, Christ. One of them. So we're going to want to move register to register. Like that. And we want to move from, which side does it end up in? In the right side. So that should be car result. Or coulda. Right? So if it does not equal the coulda result, move from the coulda result into result. Somewhere in there. There we go. How does that make sense? So maybe I just am checking the wrong one. It's probably car result. If we have a move RDX RCX, that's correct. Okay, we did it. We did it. Can now hope. Yep, still doesn't work. Well, we could have hoped. So we move that into RCX and racks. We do stuff here. We jump here. We call racks again. So we don't use racks anywhere here in between loading this, right? No racks, no racks, no racks, nothing like that. Well, now I'm at a loss. See, we have Vaj. Thank you so much for the follow. What do we got? We load lambda 0, this thing here, into racks. We load racks into GCD Euclid. We move GCD Euclid into racks, which is fine. RCX and RDX are set up. We push them, which shouldn't matter. They'll still stay the same thing. And then pop them, which shouldn't matter. They'll still stay the same thing. And then we return. And when we call racks, we jump here. Any ideas? So we pass in our CX and DX, the two arguments, and then we save them onto the stack. We load the two arguments into BX and racks and do some stuffs. We -8 RBP RBX RBX racks. Okay, so this just loads A, which was in RCX, into our BX, and then loads our BX into racks, and then jumps to the return. We move. So then we load A and B once more, just like here, and jump on them based on if it's less than or not. So test will set the 0 flag if they're equal, right? Is that correct? Do I need to jump if less than here or a different flag? Am I doing an incorrect thing with the compare and jump? Should this not be jump type 0? I mean, what is the comparison result, you know? It's just set CC, type in result. So I think set, what it does is it'll set if it's less than. So it's going to be 0 unless it's less than. Test is the same as and, except the result is discarded. Okie doke. So it'll be non-zero only if they're not equal. So if it's 0, they're equal. How do you tell if one's less than the other? What is settle? So settle's for compare, but then test RBX. Yeah, so set less than will set if RAX and RCX are less than. So BX should be set with 0 if they're not less than and 1 if they are less than. So if they're not less than, we need to jump if 0. Okay, I think it's correct. First time chat, Hassaner Keely says, building a compiler? Yep, that's what we're doing. That's where we're at right now. Hassaner Keely says, this is very interesting. I'm glad. I'm glad. I'm still trying to just figure this out. I have no idea what it could be. Why this program not work? Let's try a simpler one. Okay, handle IR type 8, which is an add. We can do that. Add. Add. Okay. Okay. That one didn't work either. It's an interesting one. Why do you think this one didn't work? So I really don't know why this one didn't work. Push the base pointer, move the stack pointer into the base pointer, sub-0 off the stack, which will do nothing. Move 4 into racks and RBX, add RBX and racks. Move racks into RBX. Move 4 into racks, add racks and RBX. Move 4 into racks, add racks into RBX. Move RBX into racks, return. Am I insane? Why isn't this working? Am I like not running the right executable and I'm just dumb? No, code 5. What am I missing here? Well, if anybody knows why this wouldn't work in assembly, that'd be great. Has nothing to do with the label. Well, what does work? It's not that, is it? It'd be dumb if it was that. Hello? Okay, failed with code 5 and no output. I'm not sure. Are we looking at the same file, GCC? What are you on about? Why? Okay. That's underscore underscore main. Okay. This is failing. Why is this failing? We're just calling main, which push RBP, move RSP. It's kind of what you do in a function. What? You're not popping RBP. Oh, rip. Rip. Did you forget to generate the function epilogue? Probably. I don't know. Yeah, we did. We did. Hey, we did it. Not that. This is why we use leave. Enter and leave, so we don't forget them. It still fails with code 5. We get some funky stuff now. Why does it have a ret? Okay, so... Jesus. This is so messy. Why would it have... Okay. So... Ugh. Yeah. Oh, it worked. Okay, we got the answer. 16. Jesus, that took too long. Simple math. Done. Please. Greatest common denominator. Okay, we can hope. We can hope. Yes, it worked. It worked. Chat. Shell command failed with code 8. That means it worked. Because guess what? The program is supposed to get the greatest common denominator of 88 and 32. If we do 80 and 32... Here... Recompile. Recompile. You can see we get 16. Look at that. Look at that. Because the greatest common denominator is 16, baby. Fuck. What do we got? What do we got? What do we got? Code.s. Run. Messages. And 32. Okay, I'd say that's confirmed. It works. Pog. Oh, our compiler works once more. I'm just gonna say it's alive. It's nowhere near done, but it's alive. Let's get a kumitu happening. We'll just discard those changes in the example. Revert the buffer. Still load in mode. Label generate, that's right, is now being used elsewhere. Right? Is it? Did we stop using it? I don't even remember. No, I think we're still using it in here. Somewhere. Yep, right there. Nope, not right there. Somewhere. There it is. Okay, let's just think about this. What is this? Unused last expert, that's all. And to do remove this. I'm okay with that. I guess we would have to do everything but IR function changes. Otherwise, we'd have to also include that change. Hello? Asked you to stage something, thank you. Pog, it's working. Okay, so we're gonna stage, oh my god. No, stop asking me shit. Just do what I say. Why is it asking me to save a file? It's not different. Oh my god. I'm gonna kill someone. Emacs, stop. Shouldn't even be modified. I don't care. Jesus. Okay. Last expr. Yep, once more. Didn't I revert the buffer? Like, what the fuck? I'm gonna die. I literally reverted the buffer and reloaded unmode before I did all that, so that I wouldn't have to deal with the save messages every time. See, this is why I usually use git from the terminal. Yeah, it's so much easier to type out source/codegen/intermediate_representation.c after git add. That's so much easier to stage it. Plus, it's way harder to have untracked files. You'd have to dig through all of these in git status just to find which ones of these are changed. Just do git add source. Yeah, if you want to just totally break the code and include changes that aren't made yet, you can do that. Turns out that's allowed. Okay. Cogen. Make label generate accessible through header. It's temporary, but it's needed. We're going to have to do some we'll include the change to IR function here. Well, we'll do stack allocation. We'll make it its own thing. We'll do a bunch of stuff here. Blocks and functions get names, etc. And we'll also do IR function. Now we just need to change the IR function itself, not in register allocation, here. Okay. Should be pretty good to go. Just to git add-p is a thing if you don't want to stage entire files. I don't want to do that from the terminal. I don't want to manually select hunks of lines. There's a reason things git porcelains exist. It's because git sucks to use. It's just true. It's not, there's no UI, there's no, you just have to type out file names and then hope you don't break things. It selects them for you. I see, so git add-p does like hunks. You don't have to select the lines. Well then, how do you like use half a hunk? Because git formats hunks weird. Or can you not? Or are you just forced to use their little chunks, their hunks? Cogen, IR, functions, and blocks. You can split the hunks if you want. Okay, so it's doable. It just sounds horrible to do from the command line. Functions and blocks now have names. Probably should have included that there. Whatevs. I can do a fix commit, or I can just, I'll just roll with it. Okay, we're just gonna do a little bit of fix up and then the rest of the crap. We just removed info from these. The thing for me is simply that I know what git does on the command line, whereas I don't trust maggot to not accidentally break something. That's fair. I trust maggot. It's open source, I can look at the code, and it's never done me wrong. So I usually do something like ga.:gc-m message::gp. Yeah, that's much easier to use than maggot. Separate commands, that is. Yeah, the semicolon only works in bash. I know what you're doing. Okay. cogen RA keep track of registers allocated per function. And then we're literally just going to go Arch x86-64 backend. Beginning of IR translation. Example / greatest common denominator. And some others now work. Hallelujah. He did it. I mean, get status just has all this crap in there. It's inconvenient for me. I agree that the people who make Git would argue that's my fault. Keep a clean working index, but no. See, Sir Aid, when you say GCO, GRA, and GRRM are also aliases I commonly use, all that shouts to me is like, you mean it's almost like you use software to give you certain sequences of buttons to run the different Git commands instead of typing out the commands in the terminal, no? If you add Control X before what you're typing, they're pretty similar. Control X, G, right? I type G, and then I go, okay, I want to make a checkout. That'd be branch, which would be B, and then B for selecting I want to check out a branch. Then you just select what branch. Except I know how aliases work and what they do. I mean, do you really just do maggot anything? What do you want to do? You can see how it works. Maggot checkout. Oh, it's in maggot branch.l. It's right here. I don't trust myself not to break something when using maggot. That's fair. I just don't know how you would unless you mash buttons. Like if you just open maggot and then mash, it could be horrible, but most of the time what would happen, I've even done that where I accidentally open maggot and I'm hitting buttons. It's never ruined anything. Not once. Because it always does a y or no, a yes or no p, a predicate, before it does crazy things. So you have to type out the words yes and then press enter. And it has to be exactly yes, otherwise it won't work. So unless you're like, you mash buttons, happen to type yes, enter at exactly the right time when it prompts you with a yes or no p, then you're not going to break anything. I promise. It is very nice. I agree that the terminal also gives you fuller control, and you get all the way, like you're just using the Git program. There's nothing on top of it that you have to learn how to use or make sure it does the right thing. I understand. I understand where you're coming from. It's not insane to just not want to use maggot, because maggot is crazy. It's like this weird half text interface, half UI with like custom keybinds that don't exist anywhere else that you have to learn, and it's scary. It is. It's a lot. And if you don't want to do that and you already know how Git works, I can totally understand. I just hate using like GitHub Desktop. That, and I don't usually use Emacs, and I regularly have to use Git on servers. I would, honestly, even if I didn't use Emacs as a text editor, I would still use it just for maggot. I would. Because maggot's nice. Okay, let's start thinking about how this register allocation stuff can work. Ged Yuko says, version control system intended to ease your version control, not to add more work to please the version control system. I'm going to contemplate on that one for a little bit. Also, Alex Sad 95, thank you so much for the follow. Hopefully you're not too sad. I get sad too sometimes. It's okay if you are. And I don't I don't know. I'm sorry, Gedyuko. I don't know what that means. I tried. I thought about it very hard. Intended to ease version control. VCS intended to ease VC, not to add more work to please the VCS. Okay, I get what you mean. I get what you mean. Okay, so you're saying the version control system, like Maggot or the terminal or whatever you're using to control the version control, it shouldn't add more work just to make the version control system, whatever you're using to control version control, easier. Which to me would be like the aliases in the terminal, but I could also see how you could argue that the Maggot makes it more complicated because you have to do more work to go, okay, what buttons do I need to press to actually make it do the right thing, right? So I'd say both are pretty valid. I'm also going to push these changes to the main. I'm like an old man. The Ukraine, you know. No, the main. There we go. Push changes to main. Those are now available. Hallelujah. And let's try and think about how we could do this. Is IR divide not a type yet? Yeah, IR divide and multiply aren't types yet. Okay, that's why it's not a problem. Those are probably still just to do. So if it needs a register, blah, blah, blah. Sorry, it says lol. Listen, we're halfway through. We're halfway through. It's working. It's working. I swear. What am I freaking out about? So when we allocate registers, we have to assume that certain registers are clobbered by certain instructions. So when we have register interferences here, ignore this. If we have register interferences here, and we say, is this the only place where we have to deal with it when we're coloring? Or do we have to deal with it earlier? Sir Aid, do you know? So the problem is, for example, a divide instruction will clobber RDX. So do we just have to say that there's an interference when we're coloring? Or do we have to somehow make it, like, do something way more complicated than that? Way earlier on. Like, do we have to, before we even... Because the div interferes with RDX. Yes, I agree. The issue is, when do we actually need to deal with that in register allocation? Like, is it when we're coloring? Is it way up here? Should it be a pass that actually like fixes it? And a mod instruction would interfere with racks. Yes. Yes. So do we need to like pre-allocate? Like, so the thing I'm getting confused about is if we have a multiply, how long does it clobber racks for? You know what I mean? Doesn't that mean that like any register that interferes with this instruction also needs to interfere with racks? One way of doing it is to include the registers in the adjacency matrix or lists. I don't know how that would work at all. That's so confusing to me. Why would you make a single matrix with both registers and... Okay. So if you did that, if you had the registers and all of the instructions that need a register, right? All of these ones that get allocated registers. If you added that to the matrix, like R0, R1, blah, 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 how would that interact? The div instruction interferes with racks. Yes. But how would that affect how we actually do things? Like, when do we use that register data? Because when we're coloring, all we check for are all the adjacencies colors, and don't color as the same as those. Gedyuko, it's okay. We have plenty of... We actually previously had a simpler register allocator. You can think of it as a temporary that uses RDX whose lifetime is a single instruction. So if I... Okay. This might be cursed, but hear me out. If we just inserted an instruction, is there any way that would work, where we could insert an instruction after a divide that's colored a certain way? And then that would mean that. But then we'd have to also update all the adjacencies with this new adjacency so that it doesn't use it, right? See, this is so messy. Which means register interferences. We just need to add something here, no? During coloring? Let's think about it. God damn it. Why? Why no autocomplete? Did I disable it? I did. Why wasn't it showing before? Okay, don't at me. I know this is wrong. Gedyuko says it was proved to be effective in Java Hotspot. Either way, you can find blah 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 PDF if interested. Okie doke. That's cool. If you want to see it implemented, I'd recommend, you know, making a pull request, implementing it yourself. That'd be cool. Have 2 register allocators. So we can say info, and then we're gonna need like a callback, right? And this is just gonna say info instruction register interference which okay. See, if we move to a bit mask here, it's gonna work out. Okay. Bit. Uh-huh. Okay. Register interferences or equals 1 to the left. This nonsense, right? Okay. Now we change things. What did I call it? Instruction register interference. Okay. Is that correct? That's a function pointer, right? I can never remember. Can never remember. That's a function pointer. That's right. Empty arguments. But it's not empty arguments. There's an IR instruction. Should include cogen forward, I think. It doesn't matter. Okay. Yeah. Okay. And then we can say info. I didn't add it there. Okay. So now we should have a callback, which is going to complain, hey, you're not passing a callback. And we're going to have to write a callback. Sure. Okay, in 64T. IR instruction. Switch. Instruction. Type. Not instruction. And we'll just assert. Yeah, cannot get register interference of null instruction. Okie doke. Okay. We're going to need both RAX and RDX here, right? It seems correct. And then multiply is going to need RAX, right? Yeah. Sure. That's only if you use the stupid multiply instruction. Okay, then we're good. We'll just say it's fine. Yeah? So this should be all we need. Okay. Accidentally alt-tabbed. Subscribe, what? Oh, I changed this. That's fair. If not, to the left x, right? And then I need to start it at 1. I do r equals x plus 1 anyway. Why are you mad? Adjacency list node. There. Shift clobbers RCX. All shifts? What's the opposite of arithmetic? Logical? Am I incorrect? I've been playing Dishonored recently. It's a lot of fun. I recommend replaying it. Logical. Nice. But Dishonored has just been so much fun recently. Sneaking around, killing rats. So we have shift right, arithmetic, and logical. And shift left, arithmetic, and logical. And they're all going to need... They all need to have RCX, right? I know technically left logical and left arithmetic are the same thing. Right? That's correct, right? There's technically no difference. Sal is the same as SAR. Okay, perfect. So we'll do that. So shift left logical. We'll still handle all of them here just in case, but just should be noted. They're technically the same. May not even let us. Yeah, it doesn't let us. So let's just have shift left, shall we? Duplicate case labels are not allowed. That's stupid. I get why, but it is stupid. So we have shift left and then shift right, arithmetic, and logical. And these are going to say CX. No thanks. Yeah. Okie doke. Oh, this isn't how this is going to work, by the way. Also, maybe if you missed it, shifts clobber RCX if the shift amount isn't an immediate value, if that helps. We're just going to say it clobbers RCX no matter what, because I don't want to even think about that. Is that correct in the mask? We should technically do -1, shouldn't we? Like this? I know. It's going to be horrible. So there's got to be an easier way to do this. Oh, there is. Yeah? Yeah. I broke it. I really broke it. How did I break it? Oh, I'm freeing something that doesn't exist. Cannot color graph with 14 colors. There's got to be something wrong. That's not right. Zero shifted to the right one is just zero, right? Does that make this like negative a billion? Zero right shifted left equals zero. Okay. That's what I would think. That's what I would expect. What am I screwing up? Oh, I'm dumb. Here it is. We need to AND this with one left X. We have a bit selector, and then we have a bit mask. That's better. Supposedly, it'll work now. So we still call IR multiply to do. So let's just test from code.s and try and do what has division in it. What example? I don't even know. Probably div test. That's a good one. Okay. In function IR divide. Okay. And we can do instruction, which is a div instruction. And then we are going to set pair and mark. Quite simple. On here, I think if I do this really quick, I'll be able to get some more stuff in the autocomplete. Let me just test. I'm loading. There we go. Yeah, snippet. Yeah, now we have a lot more stuff. Okay, just trying. So as far as parent goes, that would be div. This would be div value pair. And then this will be left-hand side, right-hand side. Which looks a lot like all the others. Don't forget to insert it. There we go. Probably should just name the instructions like X every time. I don't know. Multiply. Modulo. Oops. Don't forget to change that. So we have shift left. We're going to have shift right arithmetic. There we go. Technically, that's not sure. That's SAR. Okay. How about that? How about that? Now in the x86 64, nope. We have IRF emit instruction. Handles, it doesn't handle. Okay, that's fair. We have multiply. I mean, it's just going to be the same. There's a lot of them. Where's add? There it is. Okay, SAR. Sure. And modulo. And divide. And multiply. Sorry, it says nope. The argument for the shifts must be an immediate or CL. FMIT handles that correctly. What? What did I miss? Was that a long time ago and I just read it? What am I screwing up? Sorry, it says no. Okay. Fprintf SAR isn't going to work. I see. So what you're saying is when we... Why wouldn't it? We just have a pair. Is this incorrect? Confusion? The argument for the shifts must be an immediate or CL, says Sarade, not RCX. Okay. The IR is fine. What's wrong with the printf? Just prints car encoder ID like every other single one. So confused. This is just for printing. What? I don't even know. I really don't. Okay. Are you printing the instructions or omitting them? I mean, I was printing them there. We're in intermediate representation.c in fmit instruction, just printing out the string representation. Okay, so multiply. What do we need? Yes, I did mean imul. Ah, yes, debug printing is called fmit instructions. That's why I was confused, Paul. I mean, it's just, yeah, that's what's happening. You're emitting an instruction to a file. You could say fprint instruction. It's the same. Either way, it's not going to be confused with the backend most of the time, unless you're latently watching a Twitch stream and tuning in, going, what's this? Emit to me usually means code gen. I see. It could. It often is. We're not testing that here. So if I remember correctly, division is a whole thing, right? Whereas shifting is just going to be shifting. Sure. Sorry, it just says yes. Yeah, divide is a whole thing. All we have to do is emit a div, right? It's that simple. Yeah, simple as. Blaze of Glory TV, first time chat. What's car and cooter? Oh no. Left and right, respectively. Car is the left side and cooter is the right side of a pair. I recommend learning Lisp. It's a wonderful tool and very valuable knowledge to have. IR modulo. Yeah, it's simple as, right? And then we just emit a move. Yeah. We'll say if instruction result does not equal dx, then please move dx into position, please. For divide, you also have to emit an ICQO. Code generation term is not necessarily about opcodes. Hate this terminology, hell. Exactly. There just needs to be like a really good book written on it that uses like good terms. Even if they're new, they just have to be good and usable. People will use them. I will use them. Like car and cooter, they're good. They work. Femit will scream at you if you get something wrong. What is an IQCO? We have to like move it to octal, right? QCO is convert quad to octal. Yeah, so convert 4 bytes into 8 bytes. Then, again, that's in the wrong spot. Oops. Then do the division. And if instruction result does not equal RDX, please move RDX into instruction result. Yes? And down here would be racks for modulo. Is that backwards? Is that correct? Also, before the Q code, the dividend has to be in racks. So do we have to push and pop racks if that's the case? Is what you're telling me? I guess we already interfere with it. It doesn't matter, so we're good. We can just emit a move, right? So if the dividend has to be in racks. What is dividend again? Divisor and dividend? So it's cooter? Jesus. So if cooter result is not in... No. Yeah, if cooter result is not racks, then please move cooter result into racks. It's the thing that's being divided. In 1/2, the dividend is 1. Okay, so this would be car then. How does that make any sense? So the divisor divides. Okay. Okay. Knowing Latin would help in this case. Knowing Latin never helps. I'm just lying. Latin helps with knowing everything, obviously, because it's in everything. So if the dividend isn't in racks, move it into racks. If the result isn't equal to racks, then move racks into the result. I think this makes sense, no? Instruction value pair car result does not equal racks. Move into racks. QCO, idiv, move RDX. You got mod and div backwards. I figured I got something wrong here. FMit only accepts memory or a register operand. What did I screw up with div? So we have idiv, memory, or register. So it just is implicitly in racks. Okay. Pass only the divisor to idiv. Confusing. Uh-huh. Only accepts memory or register. Oh, I didn't change this one. Could not find register with descriptor of 0. Ruh-roh. Okay, so they're not being allocated registers. That would definitely be an issue. Subtract, multiply, divide, shift left, shift right. Nice. Shift arithmetic right. Register or immediate to register. Huh. So these are going to be tough. You forgot modulo? What? Modulo, dx, racks, divide. If you're shifting by a variable amount, then the shift amount has to be in CL. You forgot modulo, but not here. Oh, okay. Where you set the results. I did. Thank you. I appreciate that. The shift amount has to be in CL. Okay, so we'll just assume that happens then, right? Yes. So we need to store them in the RCX. So we basically need to move the count, which would be coulter, right, into one sec. We need to move the count this thing into CX. if it's not there already. We don't really have to do that because the backend does that for us. I forget. Okay. Okay. So this is the proper pattern then? So it should be shift right. The backend should ignore redundant moves. Yeah. Sounds good enough for me. Okay. Hey, it worked. Okay. Succeeded with no output. That's not ideal. What happened? 69 modulo 4. That should be, what, 1? So we should exit with 1. No? Everything seems to be working. 24 and 4 in Rax and RBX. So let's try and return just the division. IDiv Rax, that's sus. IDiv Rax would be sus. So why doesn't this work? We're getting 1. We should be getting 6, no? It was doing IDiv Rax earlier in the modulo. Yes, we'll get there. But this isn't working. Why isn't this working? This simple case. Move Rax 24, move 4 RBX, move RBX into Rax, Kukato, IDiv RBX. So we're just stomping on this Rax here. Completely. Right? Yeah. How does that work? That means our register allocation isn't doing things properly, right? Yeah, just yeet the dividend. Who needs that anyway, right? Who needs it? Register interferences or equals info instruction register interferences. King Bun says, homie found the right stream title, it appears. Yeah, it took me a little bit. I don't even know. This should work. One of these should be not 0. This is horrible, but one of these should be not 0. They're both 0. So we need to also add one for this instruction. What is this instruction? Because it has to be adjacent with itself, effectively, right? Is what we're setting up there. See, it shouldn't be allocating racks here. See, we still just get 0, 0. Who knows? What are we doing? So these register interferences, that's bit mask, hence bit masking. Was that it? Was it literally an off by 1? Am I incorrect? It was literally just, this should be 1, right? Because register interferences. No. That doesn't work. Does it? Yeah, I don't think that works. Because this is just, let's call X bit index, right? So if we get bit index 0, that means we need the first register. Yeah, so that's still happening. Which is why we do -1 and why we shift right by 1 when returning from here. So why is this on the div not being 0? So let's just go crazy. No. That. Interesting. Interesting. It didn't print anything. So node instruction is never IR divide. Good to know. What in the world? Okay, so register interference is here. I'd like to also do like if agit node instruction type. That's also never being... Okay. What is going on? It's like their uses aren't being marked. But we're setting pair and marking. What? What? Register interferences equals 0. There's none. And then there's some, but there's never some. What instructions are we even trying to color then? Are we pre-coloring? We're just going to turn on debug. It's going to be a mess. Why is divide colored? Because it's the return. Uh-huh. You know what would solve this? Instead of setting the result, we should probably just insert a copy, right? Yeah, that's probably the fucking thing to do. God damn it. Okay. Copy. And this will be an IR copy of the function return value. Given a context. I don't know why it would need a context, but whatever. Yeah. We can set the copy result to the info result register. And then we need to insert this copy after. I guess we could do before the branch instruction. Let's do after whatever we're copying, the function return value. So insert instruction A after instruction B. Function return value equals copy. Sure. It's nearer. So why is it set here? So we do function return values, and then we f-emit, which is here, the first one, and everything is fine. Then the next f-emit comes after coalescing. But that's after building the adjacency matrix and everything. Is that how long we're waiting? I guess, yeah, there's an adjacency matrix here. Okay. And 1 and 0 are apparently no good, which would be these two, which is true. Okay. And then we have, for some reason, after coalescing, it's not correct. So coalesce is incorrect, or at least I'm using it wrong. Oh, I gotta go soon. If it's a copy, you're copying yourself. Interesting. Or instruction result, yes. So this will happen. If instruction result equals instruction value reference result, they wouldn't. 1 does not equal 0, or no register. Else continue. Well, something went wrong then. Oh, no, that's a different else. Okay. So we would just fall through to here. If instruction result, yes, don't override anything that is already colored. True. And then we say reference result equals instruction result. But we only want to do that if this doesn't interfere. So we have an instruction result. We would like to apply it, but not if. Don't override with interfering register. Right? So now we can check if we have info here. We're going to need info here because now we need to actually call that thing. Remember when we got rid of that? We're adding it back. Perfect. Okay. So if the instruction reference, the thing we are copying, right? Okay, let me just separate this out really quick. Int 64t reg mask. That's going to be this thing. If reg mask and instruction result -1. Right? Yep, but it would actually be 1 to the left of that. So if register mask and 1 bit shifted by the instruction result -1. So if that bit is set according to the instruction result, don't do it. Okay, I just have to look at the code. I can't even, I'm looking at the same thing over and over. I'm going crazy. I'm losing my mind. Move 24 into racks, move 4 into RBX. One sec, I'll be right back. Ooh, I made it back. I may just be gone anytime, so the stream may cut out. Good luck. Hopefully it doesn't. We're just going to keep going. And if I may just have to go. So the stream may be ending very soon. RIP. Be sure to check out the Discord. Join the Discord down below, the YouTube as well. And all of that jazz. Okie doke, okie doke. So when we're not coloring, where is it? When we're doing coalescing. So let's just say we got here. I want to see if we ever get here. Do you see here, here, here? Okay, we see here, here, here. And we have not overridden it. So we're not overriding it there now. That's good. So now we're storing it in RBX. Yes. But these, see, these don't interfere with the div is the problem. Right? If Sir8 is still here, do you know how to solve this? Okay, we're good on the stream. We can keep going. We're good. Hey, Pog. Sir8 says, solve what? Okay, so what was happening was we were assigning the return value of a function to racks no matter what, which obviously storing div in racks, the result of that, that'll just break things inherently. But right now, we're having the operands of div they're being allocated a register racks because technically they don't interfere with div, right? Is that true? They don't interfere because they die here. They're dead here, but alive here, right? So how do we make it so that even though they don't technically interfere, they're not on each other's adjacency lists, we still need to make them interfere. You see what I'm saying? Because div is being stored fine, but racks is being, the dividend is being stored in racks, which means that when we try and move the divisor, right, into racks, then everything's breaking, or the dividend in racks. Am I right? Am I incorrect? Am I misunderstanding? This probably has to be car, right? Am I incorrect? So we need to move the dividend into racks, right? The thing that's being divided by. And then when we call idiv, we pass it coder. That would make sense to me. The dividend should be in racks anyway. Well, it should be. So what if, but here's what I'm saying. There's no reason that the divisor couldn't be allocated racks because it's not interfering with div. So how do we ensure that the divisor isn't put in racks so that we don't stomp on it when we do all this stuff? Or does it interfere with div? But then how can they both be assigned R2? Do you see what I'm getting at? It seems like something has to interfere that doesn't, because King Bun says, yeah, both assigned R2 is weird to me. It is weird, but that's correct. That's actually what we're trying to have happen. Because when you use for, you can use divide by RBX, and then after you get the result, copy it into RBX. It's totally fine. I suppose div needs to interfere with racks in general. It does, but that's not the issue. That way neither operand is assigned racks. The operands don't interfere with div, so they'll never be checked for during register allocation like that. These are not live here. They die here. The coalescer can then combine the first operand in racks. Again, that's happening. I agree. But the problem is that they don't interfere. So that's actually never checked. The divide instruction doesn't interfere with it. You know what I mean? Or doesn't interfere here, otherwise they couldn't be stored in the same register. But they can be, because you can divide by 4 and then store the result into RBX, because we're no longer using the number 4. Do you see what I'm getting at? Am I insane? Am I just rambling? I feel like it makes sense. What if this is in racks? There's no reason it can't be. Sraid says, yeah, I know, the situation is rather annoying. Mr. Mugume, 20 viewers? You are famous. Thank you so much, Mugume. It's so good to see you back here. How's it going? Thank you for tuning in. King Buns says, okay, I see now. Nice, King Buns gets it. That's good, that's good. I'm not insane is probably what that means. So we can use the number 4 to divide by, store the result in that same spot. Totally cool. But what if this happens to be in racks? Won't everything break? Like, everything will very vehemently break. So we just need to make sure that this isn't racks. Register allocation must not allocate racks to divisor of IR divide. Yeah, that's cool. Basically, you have to make it so that both operands interfere with racks and RDX. So we're just going to have to do another pass, is what you're saying? So like in register allocation, we're just going to have to do another pass with pre-allocations? Or how do we you see what I'm saying? That doesn't make any sense. The reason that doesn't make any sense, I don't want to just say that doesn't make any sense and then say nothing. So the reason that we can't make both operands interfere is because how do we know it's an operand when we get to it? We're allocating in order, so when we get to the first instruction, there's no way we actually know, hey, that's an operand of a div. You're checking every use anyway, right? You can make it so instructions can interfere with hardware registers. They they do, but I get what you're saying. So here's the thing. When are we not checking? When are we setting this up? So when we color, we're just saying check every adjacency, and then if there are hardware like register interferences, add them. But that's only in the adjacencies. So you're telling me we have to also loop through the uses and do the same thing? Is that correct? So like I loop through every use and then say, hey, since it's used there, we don't want to interfere with it? This seems so crazy. Does it not? I feel crazy doing this. This feels insane. Okay. That information should be computed when you build the adjacency matrix lists. So when we build the adjacency, well, we build the lists from the matrix. So what you're saying is the matrix. But I don't want to alter this. How would you recommend I alter this? I don't know how to fix it here. Do you know how to fix it here? I know how to fix it in coloring. I'm pretty sure it'll work. I don't know what to do here. Yeah? Because they don't interfere. Do we have to loop all through all the uses here? Either way, we're looping through the uses. It doesn't really matter, right? And hey, look, it worked. I can put it to do if you think that's what it's for. If it's like really that bad of a thing. I don't think it's that bad of a thing to do. Thread said it's we shouldn't need uses here. Oh well. This should be done before coalescing, ideally. Ideally, if you know how. I mean, you're saying a lot of facts. Everything you're saying, 100% correct. If you know how, go for it. Let me know. But I don't know how. This is how I know how. This fixes it. King Bun's straight out here spitting. He's spitting bars, facts. It now works. I do want to mention, it does now work. Because ideally, the coalescer would then combine the divider and racks, the dividend and racks. I mean, ideally. I don't know. I don't know how else to solve it. Because they don't interfere. So do we have to like go through and say, yeah, I don't know. I think this is fine. I don't know how else to solve the issue, so this is how it is for now. Ideally, Surraid says, I guess Surraid says ideally. Ideally, this should be done before coalescence? What is the act of coalescing called? The act of coalescing. What do we got? Also, just shout out to everybody here. Thank you so much. I'm so glad I can continue streaming. Didn't have to stop. Coalescing. Oh, Lamau. You just said it. What is the act of coalescing called? I like how you said active instead of act of. That's pretty funny. What is the act of coalescing called? But coalescing, like, okay. My condolences, Mr. Mugme says. I'm gonna get so fried. If you guys keep using these long C words, I'm just gonna be like, that's all I'm gonna have in my brain. Okay, that works now. Does this work? What should the answer be? 8 to the right 2. 4, 2. It should be 2. This should be 8? We're not moving the answer to the right place, are we? Yeah, we're not. So we just need to add in the moves. Like we do here. Not like we do there. Like, so I'm not even doing it for multiply. Okay. So we need to move. Like this. I think that's correct. Move from racks, move from our DX, and then we have shift left. Shift right. Okay. There we go. So what was happening there was we were calling shift arithmetic left, but we weren't moving the result into racks, as we should have been, which is the result register of the instruction. Okay, last one. This is the one that broke last time. Or at least was broken. Yeah, it looks better now. We're no longer dividing by racks. Failed with code 1. Hey, that's correct. So what if we do 70? Here, let's just do 5. That way we'll get 4 as the answer. Hey, and 4 is the answer. Look at us. King Bun says, I already beat you to the so fried part then. I've just been streaming for 5 hours. It all wore off. It actually works. Oh my. Oh my. Emacs side windows are acting weird. Okay, okay. Sorry, nice. King Buns, nice. That's nice. You're like Joe Pera. Nice. 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 Home run. Nice. Nice. Does anybody know what I'm talking about? If you don't know what I'm talking about, you should go watch Joe Pera. Here, I can bring it up on stream. I'm not gonna freak out about it. Adult Swim is usually pretty cool about copyright, right? I'm not profiting off of this basically at all. Here it is.
If I didn't tire myself out, I would lie in bed the rest of the night with my eyes like this. Anyhow, after I received that message,
Audio Jungle.
I did the same thing
Audio
I
Jungle.
usually do when stuff like
Ah.
this happens. I went to the batting cages. It's tough to worry about women when you're focused on fastballs. And also, it feels good to hit stuff
Just my
with a
Audio
bat.
Jungle's making me laugh. I'm so dumb.
Nice.
There it is.
Nice. Nice. Nice.
Oh, it's so good.
Home run.
Home run. I'll link that in chat. And also in the description of the video, if I remember. If you haven't seen that, you should go watch the full hour. It's so relaxing. It's like, there's nothing more relaxing you can do. 23 viewers. Thank you all so much for watching. That's so good. It is great to have you all around. So we basically just went through and added a bunch of math. That's not bad. That's not bad. I might have to check on something. Might be good. Okay, should be good. Should be good. Uh-huh. Do. Argument registers, x64, our instruction register interference. Yeah, more math. A little bit of math there. And yeah, some more math here. It's all graph theory. It's all math. Okay, code gen. IR. Support. Multiply. Div mod. And shifting. Bit shifting instructions. Sure. Do a little pushy after I commit to commit. And look at us, look at us. I probably lost all my viewers to Joe Pera. He's so relaxing and so nice. Saraid says, I like the colon. Yeah? I've started doing that. If it's like, the main topic is code gen, but within code gen it's IR. I've started doing like the C++ namespace thing with the colon. I'm glad you like it, Saraid. I'm glad you like it. I do like it a lot as well, to be honest. It's very helpful. Just like namespaces. Not gonna anger anyone by saying that. What have I done? Okay. Well, that works. That works. What other examples do we have? Downwards funarg? Can we pass arguments downwards through, or pass functions downwards? I think we can. Ooh, look at that. Failed with code 6.9. That's no accident, folks. That's no accident. Oh, this took so long. I've been streaming for 5 hours. Christ. Stay hydrated. I'm going in another one. That is no accident, folks. Oh, that's so good. Okay. This is actually surprisingly working. What other examples do we have? I just want to make sure. We'll try out factorial. That's very recursive. It looks like it may work. Failed with code 1. Yeah, I don't think it's gonna work. What's the issue, folk? What's the issue? Whoops. There's the 1. Let's just make sure it's not supposed to return 1 first. Factorial of 5. Is that too big? Yeah, we're still just getting exiting with code 1. So that should be 6. It shouldn't really be too big at all. Yeah, it doesn't work. Okay. 5 factorial is 120. So we should be able to see that. But we're still just exiting with code 1. So at the end here, where are the different places? Right. So we have the main function doesn't look too insane. We load L0 into racks, racks into fact, fact into racks, 5 into RCX call racks. Again, we still have to handle that. It's fine. The number to the left of the number of lines in your mode line is the number of chars in the buffer, right? Bytes, but yes, not characters. That's actually the byte size. So you'll see if I go to like a large file, it's 49 kilobytes. But it is in thousands. So yeah, that's 49,000 bytes. Because if so, go to the factorial example and check that number. Oh! Oh! No. Sir Aid, how'd you even notice that? That is incredible. Is that real? Oh, I don't want a directory listing. I want dured. It's it must be the number of characters then, because it's 129 bytes. That must be the number of characters. What's 2 bytes in here? I just saw 120 and was like, wait. Factorial 120. It's like it's giving us the answer. But if I add anything, yeah, it's just like if I add anything, even a new line, it's 121. That's such a crazy coincidence that has to do with like the syntax of the language and how we, oh man. Oh man. That's crazy. King Bun says, you reading the IR sounds like a Dr. Seuss story. Looks like we have found the perfect program, lol. That's right. We're never getting rid of this syntax, the lambda duplicate. It's a factorial quine. What is a quine? Okay, now I gotta look up a word. Quine? A program that produces its own source code as output. How would that work? Because you can't just printf your own source code, because then your source code would include a printf of its own source code and so on. So you'd have to like systematically, oh man, Quine is cool. That is very cool. Okay, where are we at? Why not work? What happened? Isn't that pretty much homoiconicity like Lisp? I don't... No, it'd be like if it prints out, like your output, your print output, standard out, gets filled with exactly your input source code. That generates the print to standard out. Does that make sense? Is that correct? Because then you could print that to a file, compile that, run that, and then it'd do it again. That's the idea, right? So when we jump L5, okay, so that seems fine. We're not pushing and popping racks here. We call racks, the return value gets stored into racks, and then we return. That's jumping to the wrong place. No? For example, user bin env bash ncat $0 is a quine in bash. I can't type new lines in Twitch chat, so I use /n or actually. That makes sense. That makes sense. So you basically, yeah. You use bash to concatenate the file. User bin cat also works with a shebang. Yeah. You just run cat on itself. Oh, crazy. Yeah. Very cool. Very cool. Quines are interesting. So it seems like we're returning 1. Which we should, if we look at the factorial example, we should return 1 here. But then that should go here to n minus 1. So here you can see we load factorial, the function. Why are we moving things into RBX and RDX? That's just loading n. Okay, so we load n, load factorial. Why do we do it in that order? What? Oh, because of this. Load n, load factorial. Figure out how to call factorial. So we move -8 BP into dx, 1 into cx, sub cx dx, which means n minus 1. Okay, so we did n minus 1. Store that in our cx. And there's just one. Yeah, just one. So that's n minus 1. And then we call R8. And then we pop all of these. IML RBX CX BX racks. BX is not used anywhere in here. So it still just contains n. And CX contains whatever it did before. How does that make sense? Oh, function calls aren't moving their... I got it now. I figured it out. Yeah, so IR call, it doesn't actually omit the move thing that we've been doing. That thing. So move racks into result. Thank you very much. Did that still not work? You think that one would have worked. Sred says, also, since you like Lisp, lambda x.xx lambda x.xx is a Quine in lambda calculus. What is x.xx? So what does our dx and our cx contain? Our cx contains the new n minus 1. Our dx contains n minus 1 as well. Mr. Mugame says, I heard the word calculus, I'm running. If you like Lisp, you'll like calculus, ironically. Lambda calculus. It is scary, but it's not too bad. It's just big words for small things. Move racks RCX. So we call R8, which is fact. It should set racks and return. We'll set racks to RCX, multiply n, and the return value. What am I forgetting? N is 5. N times fact of 4. N is 4. N times fact of 3. N is 3. N times fact of 2. N is 1. No, N is 3. N times fact of 2. N is 2. N times fact of 1. Fact of 1 returns 1. 1 times 2 equals 2. And then that'll return and get us to, see, that should be the factorial implementation. What could be the issue? I honestly don't know why this isn't working. Failed with code 1. It's like it's returning this, right? But that wouldn't make any sense because this should be nested. So maybe n is less than 2 is broken. Is this broken? Rax contains 2. Bx contains n. Compare 2 and n. Set less than CL. Is this backwards? Saraid says your factorial implementation is fine. Yes, I'm just trying to figure out what's wrong. So I'm going through like, okay, what's it actually trying to do? What's the issue? You know what I mean? Why are we returning 1? So when we compare, are these in the wrong order? Compares like sub and AT&T and it's backwards. Well, you can say that. I don't think that helps me in this scenario. We have 2, we have n. We're comparing 2 and n, and then checking if the less flag. Compare AB is B minus A. Okay, so BX, n minus 2, and then we settle CL. So like, do we need n and 2 or do we need 2 and n? Know what I mean? We're trying to figure out if n is less than 2 and branch to the false if it is not. Hopefully that's fine. It was a giant bang. Don't know if you heard that. So when we compare, which way does it go? N is less than 2 would make sense if it's backwards, right? So n is less than 2. That'd be the right way round, which would mean that this gets set properly, which means we jump to the proper place. But if we don't jump to the proper place, that would explain everything that's going on. Because we're just returning 1 right away instead of, not. I'm going to try it. It may have been me passing them backwards too. The operands. Still fails with 1. Okay, that wasn't it. So comparison. See, yeah, we passed left-hand side, right-hand side. I wonder if we could... we really need strings. Technically, we should probably only check adjacent. We should only check adjacent ones to the call. That way, that's only if they're live. We'll get there. It doesn't matter right now. In my branch, I'm doing register to register, right-hand side, left-hand side, if that helps. Oh, I'm using the same one you are. I didn't alter codegen comparison, right? I'm just calling it. That's it. Didn't alter it at all. I'm convinced we're using the same comparison. I just don't think it's working because we're still returning 1. And the only way that can happen is if we jump here, right? Or if this ret does like the way wrong thing, which I don't really know how that would happen. Push, push, push. Pop, pop, pop. Push, pop. What's the assembly yours generates for the for this problem, for the factorial? I'm honestly curious. Feel free to post it anywhere in the Discord here. Or if you don't want to, that's fine. It's not on you. Sraid says, I don't know. Let me check if it even works. Lol. That's a good idea. Move 2 into racks. Compare racks and RBX. If n is less than 2, set CL, test CX, jump if 0 to L4. Interesting, interesting, interesting. So this assembly isn't working. Move 1 RCX. Sub 1 from RDX. Move RDX into RCX. So that's n minus 1, which we then pass to R8, which we then... We're pushing and popping our CX and our DX. Ah, I figured it out. I figured it out. Your boy figured it out. Okay. Guess what I forgot to do earlier? The other half. Yeah, remember this? Because I sure didn't. I mean, we could also just say if this is not is caller saved. We'll just do that. That way we don't have to do this crap. Not like that, please. Okay, there. Okay, I'm pretty sure I figured it out. Soraid says mine seems to work. Yeah, I think I figured it out, Soraid. Thank you so much for testing. I put it in general if that helps. I am curious what it looks like. Section data. Space 8, return value, space 8. Oh, I forgot. It'll work on yours. It'll for sure work on yours, I promise. So the problem is that we're not doing callee saved registers. That's our only issue. So when we enter a function, right? Where is it? Oh, Christ. So when we emit a function, we could do it in CodeGen Prolog. We'll just do it here. Did I forget CodeGen Epilogue? Why is it not here? Oh, because I did it in return. Note. Epilogue is generated by return instruction. Mr. Mugame says, wait, Eternal and Soraid are the same person? Soraid says, perhaps. Perhaps. Epilogue is generated by return instruction. So after our prologue, we'd like to do some pushy, right? So for all of the functions used, we did the same thing in register allocation, no? Looping over bytes or bits. When did we do that? I can't remember where we did that. Sir Aid says, Sir Aid is just the old Irish word for eternal. Oh, I didn't know that. That's cool. Mr. Mugame says, that makes a lot of sense. What the fuck? It does make a lot of sense. I'm just going to times 8. if function registers in use bit shifted to the left by 1 left I, so save all callee saved registers are used in the function. Okay. So if they're set, that's also totally not correct. If function registers in use and 1 to the left I. Sraid says, you can also check my profile on Discord. I've linked my GitHub account. Ooh, nice, nice. I see, I see. So when we do this, it's going to create a whole problem, but whatever. Save all callee saved registers that are used in the function. And is callee saved I, right? Where else did I do this, by the way? I'm looking for times 8. What? Grep? Hello? Okay, there we go. I had to escape the star. Okay. We're going to do the same thing. We're just going to do it down there. Where's emit function? Okay. Boink. Okay, now we can just get funcregs. Placed with function registers in use. Okay, all of this is unrelated. I got rid of the comment I didn't want to get rid of. Save all registers in use in the function callee saved registers. Okay. This can't happen here. It actually has to happen at the epilogue. And that looks correct. I is greater than 0, right? Okay, so now we push racks in RCX and then pop RCX. Uh-oh. Did I do that wrong? IO return. Limit pops. Ah. Probably did that incorrectly at the beginning. Yeah. Okay, error register name. Could not find register with descriptor of 32. Huh? Well, why would it be set? What? When are we saying that? Okay. Something like that. Why are you mad? Okay, it's just an int. It's only one. 32? You do know this is x86-64, not RISC-V, right? Well, yeah, but how does this even happen? How does function registers in use and 32 happen? Like, what? Is it happening in the proper order? It is. How is I32? What? So this should prevent it. So that means registers in use has the 32nd bit set? What? Why? So just print this number. If anybody remembers how to print binary in C, let me know. Uh, 11. Well, that doesn't make any sense, because I32 is not set within 11. That would make it like a billion. What? What did I do? 1 to the left I. What? Okay. Let's just think. Let's just think. Maybe it's not here. Right? Maybe it's in the other place in return. Yeah? Where's return? Jesus. Ah. We're just... Okay. Fun. That's because a switch statement, all of the branches share the same scope. Is that real? What? Who designed this language? Tell me who designed this language, please. I'm doing the back of the hand smacking. It is time, okay? It is time. Who designed this language? I need to know. This is awful. What are you telling me? I can use a variable from another switch? How? That can't ever happen. That doesn't make any sense. What? Okay, am I insane? Am I insane, chat? Am I just some rambling, crazy programmer on the internet? How is this language even functioning? How can we use something that's just not in the same scope? Is it because of the stupid block scopes in C? We're technically within the same block, and these are all just labels? Sarade says Dennis Ritchie. Okay, I blame Dennis Ritchie then. What is this? Why is this not a compiler warning even? What? It's okay, it's a maybe uninitialized. That's what warning we get. Maybe uninitialized. What? Maybe uninitialized. It's in another scope. Sfraid says cases do not open a new scope unless you use a block statement. Okay, well, that's dumb. That doesn't make any sense. When would that ever be used in a real program? I would love to see it. I would love to see it. Ah. God. Okay, I may just be insane, but still. It's just, it doesn't make any sense to me. How that, what? Why would these share a scope? When could that ever happen? Straight says this is C. C doesn't make sense. What? Okay, now you really are confusing me. What? Expecting switch statements to make sense is asking a bit much, I guess. Basically, the rule of thumb is, if you have a declaration in a case, put the entire case in braces. Why? Why would that be required? I get, like, oh, that way we can just, it's easy on the compiler. Who cares what's easy on the compiler? It should be easy on the programmer. Is registers in use just being set incorrectly? Like, what is happening? I equals 32? It starts at 1 and gets added to 1 every time. Is Kali saved? Yeah. Okay. Sraid says, because if you don't do that, this happens. Well, yes, but it's also, that wasn't the problem. That's been fixed, and it still doesn't work. It doesn't make any sense. Why is it saying that so this math doesn't even make sense to me. Function registers in use is apparently 11. Yeah? You can use Emacs. 11 is what? Let's just use our brains. 11 would be 1011. No? 8, 4, 2, 1. 8. Right? 8 plus 2 plus 1. 11. How is the 32nd bit happening? What? Okay, is something being cast? Maybe it's being cast to an int for some reason. Right? Like, I is a size T. Yeah, that's fine. So that's not happening. I figured. It still doesn't work. Let's just put braces around this in case the and is happening at a wrong time, but it's not. Okay. Regs 11. I 32. This is an and. So if this is not true, we should just skip it. I don't get how this math works out. I really don't. What is this? Fucking what? So the 32nd bit of 11 is set to 1. Let me just... Are we printing it out as the wrong thing? Right, so technically this is 11. And this is 1 to the left, 32. Why are you mad here? It's telling me it's an int. So just make one of these not an int. Yeah? Zero. Okay. What? Why does this make no sense? How? How? How is a... What? Okay, it's got to be some type nonsense happening. Like, what is even happening? It doesn't make any... It doesn't make any sense. Try casting everything to size T. Oh, wait. I think I just fixed it. Yeah, I did great. Now it crashes. How does that even work? Now it crashes? Oh my god. I'm... It now just doesn't work. Do I even... What? Why is it just crashing now? What happened? What happened? I was building it. I cast this to a size T, and now it doesn't work? Sir Aid, I found a compiler bug. Something's going wrong. I don't think this is me. I cast this to a size T, and it crashes. What? What? Doesn't make any sense. Everything, that's already a size T. We don't need to cast that. We'll cast this. And it crashes. Okay. Is one of these crashing? Is it a printf? What's crashing? Fuck. Okay. If the unsigned type has conversion rank greater than or equal to the rank of the signed type, then the operand with the signed type is implicitly converted to the unsigned type. So one should be promoted to size T automatically. So yeah, but when I put size T here, it literally crashes the program. Look. It's fine. It's not fine. First time chat from Natsu130. It's crash elsewhere. Are you sure? I mean, where else would it be crashing? By me casting this? What? How does that make any sense? So 1 to the left eye is not the same as size T1 to the left eye. Shifts do not undergo integer promotion. So why would this break? Why can't we even get here? Nothing. Natsu says in the finale return, in the final return, you know it would help a debugger. How would that help? We already know what all the values are and what's happening. We just don't know why it's happening. We're not going to the debugger isn't going to go, hey, fix this line right here. This is wrong. Right? It'll just tell us where it's crashing. Okay. We'll do the magical debugger. We gotta run it with what? What are we trying to compile? Factorial? I'm just saying, last time we used the debugger, it wasn't needed. That is what I'm gonna mention. Ugh. Hate this fucking debugger. With a breakpoint, can't you step through and hopefully figure out why the values are going where they are? It's just crashing. Okay, whatever. We're not even able to print anything out. Instruction block was null pointer. Fantastic. How? Doesn't make any fucking sense. Ugh, this is so annoying. See, this doesn't insert the branch. I don't know, whatever. Okay, are you gonna be done now? Okay, still exited with code 5. Wonderful. Why? What is it? Instruction is return. How's block null pointer? What are you talking about? Ah, I'm gonna kill someone. Okay. IR return. Of course. Yeah, why? Ah. I put a screenshot of the integer promotion nonsense in general. 1 to the left 32 LU. Shift count is greater than width of type. What in the hell? Why? I hate C. It's like C is almost perfect. I love how it's low level. I love the syntax. I love everything. And then it just, like, with the semantics, it just crushes you. It goes, by the way, it fucking sucks. It's so bad. Like, come on. And then Rust comes along and solves an entirely different problems that programmers aren't even having. They're like, oh, you know what the managers at your job always ask you for? What if you could just write code like that? It's like, oh yeah, that's great for the managers, but it's not easy to write that code, and it's not fun. I don't get it. Jesus Christ. We're getting somewhere. What W conversion is for. Okay, Jesus Christ. Also, whoever said it was crashing at the finale, Natsu, you were correct, that's where it was crashing. But we were still having the same problems with integer promotion bullshit and shifts happening. Both occurred. Sraid says, which is not enabled by wall or Wextra, sadly. You have to enable it separately. Okay, that's the same thing as C. Like, enable all the warnings, but oh, it's actually not all of them. Fucking C. Jesus Christ. I can't stand that. Not only do you have to do wall, not only do you have to do Wextra, not only do you have to do pedantic, no, you have to also add W conversion. You have to know that magic. Jesus. King Buns just makes again, exactly what I said. Rust comes along and solves a problem that no programmers are having on an everyday basis. You reiterated what I said. Nobody goes, I wish these programs were all memory safe, even though it took me 4 times as long to write it. Nobody's saying that. They're saying, man, I wish this worked now, today. A problem that broke Linux security sounds like a minor thing. Linux security doesn't exist. What are you talking about? Everything breaks Linux security. Every week there's a new Linux security bug. And there's like 1,000 that I'm sure are known about. There's also W undef, W shadow, and some other warnings too, lol. Okay, we did it. We're getting output. Is it working? Please. I don't even... What did we just fix? So now we pop RBX. Do we push RBX? We don't. What the fuck? Oh my god, I'm so annoyed. I'm so annoyed. Okay, we do. It's here. I was looking at the wrong spot. Jesus. I was like, if we don't push RBX, I'm gonna die. I'm gonna die inside. I swear. We now pop RBX after pushing it, which means that when we make this call, RBX won't be stomped on from here to here. Look at that. Which means it doesn't fucking work, apparently. What? How are we returning 5? Oh my god. We're not moving multiplication into the proper place. Why? What did I do? What did I do and why did I do it? It's the cooter. Thank you. Fuck. Oh my god, it worked. Oh. Chat. Oh. Oh. Layla Hoon with the follow 7 minutes ago. Thank you so much. Zoraid says, Pigo. Pog. I like Pico. Pigo. It's like a better Pog. A little higher than a Pog. Up, go. Oh, let's just test that this isn't random. This should be 24? No. Yeah? 2 times 6 times. Yeah. Recompile. Run. 24. Hog. Pigo. Yeah. Okay, we did it. Oh my god. Okay, that was rough. I am sorry, everybody. That was rough. Okay. CodeGen. Call E saved registers. Turns out that you can't just save caller saved registers and expect things to work out. Whoosh. Okay, what doesn't work now? Let's try more examples. That's what we were doing, right? factorial, and we could do C calling and calling C, but I don't want to do those because we have to compile C. It's going to complicate everything. Arrays. IR store. Okay. That's fair. What does store actually do? It stores data into an address, right? Do we not even have it as a type? We don't even have it as a type. IR store. Store data at an address. Why is this neither a global or a local store? Because it's just any address. Okay. And then we're going to have kind of like that. Okay, where do we get to now? Oh, no. Well, I sure gave up on that one, huh? You kidding? What? Oh, Suraid. Also, the worst example of how C handles warnings IMO is -w return type. Oh my god, you're so right. You're so right. It's so dumb. Why can a function that's supposed to return something just not have a return statement? How is that a valid program? Like how C is barely even type checked. It's like nothing is ensured. The semantics of the program are not ensured. They're all warnings. It's like warning, everything will break if you try and compile and run this. That's called an error. See? That's called an error. But no, they're all warnings. That's why I always do w_error equals return type. Yeah. It's worth it. But then you try and use MSVC to debug things, and guess what? You have to remove them anyway. Surprise. Why are we not doing this? Create IR immediate to load offset into temporary. What? So we have an address, which is the beginning of the array. Then we're supposed to offset memory address by index. Now we already have our byte offset, right? Right here. We have our byte offset. So we want an immediate offset memory address by index. So IR immediate, why do we need that? To load offset into temporary. Then generate an add between the new temporary and the result of the loading array's address. Should this not all just be handled? Okay, question. Suraid, does LLVM have IR array index? Is that an instruction? You know what I mean? Where you have like the base size of element, and then LLVM has get element putter. It does everything. Okay. So we have IR array index, which has the size of the element and then the index, right? Does this make sense as an IR instruction, or should this be lowered further in the IR? Serade says it does everything. Struct indices, array indices, pointer arithmetic. Okay, so LLVM isn't going to help us here. They're just a monolithic. It makes sense as an IR instruction, I suppose. Well, then I guess we just do it. But you can also lower it if that's what you prefer. Well, we could, but then we're not going to be able to take advantage of, like... Okay, we'll just add a to-do. To-do. We should probably have IR array index or something as its own instruction. That way we can take advantage of hardware address calculation. Sure. But yeah, LLVM just has the get element pointer instruction for address calculations. RIP. Okay. So we're gonna lower it for now. So we're gonna say make an immediate, which loads the offset. Then make an add, which creates an IR add of offset into the base address. No? Something like this. The offset's a number, so that's immediate. So we add, might want to swap these around. That around, please. No? Okay, it almost worked. So add the immediate offset to the address, and then index. What does index actually return? Node type index. A load local. But these have already been inserted. So we have to do this first, don't we? Like that. Yes. And then the symbol load memory address of the beginning of the array. I guess we can do that either way. Okay, I'm dense. Hold on. So now we have this final thing. This address is now an add result. So we load the offset, we add it to the base address, which we've loaded. And then we need to load. Does this just return the address? It just returns the address, right? So then we need to say are we just using expression result here for funsies? Do we have to use expression result? What if it generates multiple? Well, maybe we never actually need it. Either way, it would be the add. Failed with code 1, handle IR type 2. In intermediate representation femit instruction. What's IR type 2? Load. Okay. IR load? Where are we getting one of those from? A dereference. That would make sense. Okay. Sure. We'll just add it to the bottom. Nope, to the bottom, please. Thank you. Above those. Load. What does load actually do? Load just gets the value at an address. So we're going to have something like that. Okay, so we load there. Perfect. So to do this, what do we do? We just need to see what else we need to do. Handle IR type 22. What's that one? IR store, okay. Store data into address. Is that how we did it? We'll have to look. I see a lot of things happening in chat. Serade, if the right brace that terminates a function is reached and the value of the function call is used by the caller, the behavior is undefined. That's all the C standard has to say about this. Undefined, not ill-formed. That doesn't make any sense, man. It really doesn't make any sense. So, IR store. The address is on the left-hand side. So this should be backwards. Store data into address. Sure. Store 16 into 20. Looks right to me. Now we have, in the back end, handle IR type 2. Okay. Case IR load and store. IR load. We're basically just going to do a move from memory to register, right? Sure. Okay. Now, what is this? We have base pointer offset. I don't know what this should be. This should be not there. Is that a possibility to have a move from memory without one of these? Does reg none work? So when we load, we're going to want to load into the instruction result. But the actual address is going to be another register. Am I incorrect here? Serade says no. You need a register to load the value into. What do you mean? We have one, as well as an offset plus base register. There is no base register or offset? Okay, so you're saying we need an offset of 0 with the base register. What was that bug? Jesus. With the base register being set to the proper thing. So when we load like that, that apparently works. Hopefully. Let's do store register to memory. So we would like to store register to memory. Skipped it, classic. We have context I move, register to memory, source address 0. So this is going to be hair cutter. And this is going to be instruction value hair car result. Register name, okay. Could not find a register with descriptor of 0. Let's think about this. So local store, where are we at? So we have store 10, which is 420, into 14, which is load 13, which is just loads the data at this. Load, okay, Jesus. I mean, these all have registers in these stores, 22, 26. All of these results are set. What's incorrect about this? Maybe it's something about how I'm making the store? Did I just screw up local store when I shouldn't have? That was probably my issue. Yeah, I screwed up a local store. Oopsies. Don't mess with that. I want to mess with store. This one down here. That was probably my error. Yeah. Okay. So we would like to, how did we do it? Register to memory. So we have a base pointer offset. So we have, okay, what do we have? The right side. And then, source address offset. Okay, source address offset. Source. Pair.car. Address. Okay. That makes more sense. I was looking at the wrong place. It now compiles. Pog. The enum defining register to memory should have a comment describing the order of the operands. Yes, but that's not what I ran into first when I searched upwards for it. See, I found it here, source address offset. But I also found the answer here, which means I got to avoid all that extra searching, the extra 4 button presses or whatever. You're right, though. That would be a better place to look, is just to jump here, which means I would just have to double tap, quadruple tap, Control S in order to find it, and then triple tap to get back. Is it just 3? Might just be 3. Yeah, it's 4. Okay. Craziness. Okay, so now everything should work. And it didn't. It didn't at all. Something went horribly wrong. Load int array, move racks into first int pointer. Yes. Lee int array into racks once more, okay? This doesn't seem right. We're loading the effective address of int array into racks, and then we're moving the address into first int pointer. Oh, that actually makes sense. So this is a pointer to the first int. We load the address again into racks, and then we access the data at racks, at this int array, and move it into racks. Then we move racks into first int. That actually makes sense. 69 into racks, Lee int array rip racks, move 0 racks racks. So load again the 0th integer, move racks into racks. That doesn't make any sense after all of this. So we're not setting uses properly, is what's happening. That's what it looks like. We're using racks like way too much. IR store, we set pair and mark. IR load, we mark used. The address is used by the load. Okay. I don't know. What's the issue? What's like the specific issue? We are trying to, it looks like dereference. Okay. So this should return 69. It returned code 5. So we're doing something wrong. Uh-huh. Okay, int array. Array at 0. Move 0, racks, racks. Move racks first int. That's that line. Move 69 into racks here. Lee int array rip into racks. So when is the 69 used? It's used in a this is complicated. '69 is used here. Why isn't it being... Okay, so we move 69 into racks. We try and get the proper address. And then we try and move this into the proper address. But this, being racks, is no longer valid, which means that an array index what does that mean? Is this a dereference? What is this? Why? First int pointer. First int. First int pointer. First int. Store? We looked at IR store. And it definitely does the right thing. Are we not using? I mean, here's IR store. There's no custom store being inserted or anything like that. No IR load being inserted. We're just using IR load helper function right here. If anybody has any ideas, let me know. So 6 should be used by the store. Bleh. Why is it not? So the store, what is that generated by? It's generated by the variable reassignment after we cogen the left-hand side. So it doesn't think that 6 is being used here, or at least it doesn't during generating these. It's not, Saraid. You can say it a million times. It doesn't make it correct. It's clearly allocating RBX to things that it thinks it needs to. It's just that the use calculation is incorrect, causing a bunch of bugs where it doesn't know that things live that long, which means it chooses racks most of the time. Yes, yes, yes. So we call IR store, and IR store marks used, sets pair and mark. And we insert the store. So is it possible that we're not doing use calculation on things that don't need a register? It's like the uses are completely incorrect. I don't know. I mean, IR add sets pair and mark as well. So for some reason, register allocation thinks what? That's definitely not correct. So it's saying that Load 7. 8 has no adjacencies. I got nothing. I thought long and hard on it. I got nothing. And it seems like all of you do as well, because there's no one jumping in and saying, it's obviously this, dummy. Yeah, I got nothing. Why would it not be used? Why, like, are we just not inserting uses properly? The fuck? These all insert uses, but these are just using whatever they want. It's disregarding register interferences for them. It's like, oh yeah, we'll just store them in BX and AX, ignoring the fact that they're about to be used. Doesn't make any sense. So it has to have something to do with like instructions interfere, this whole thing, right? So don't these, isn't this a problem? These aren't being used. We're looping over all A and B instructions in the collected list, but that means we won't ever get these uses, no? Isn't that right, Saraid? Because we'll never, if it doesn't need a register, we don't add it. But if it doesn't need a register, it still has to deal with register allocation. So it says, I'm not sure because honestly I'm rather tired. Now, the sleep. I think I'm gonna go to bed now. Alrighty. Good night, good night. Sleep well. I got nothing. Unless somebody knows how to solve this, we're just gonna end it by reverting all these changes, basically. Because they don't work. Saraid says, I have been awake for 21 hours, so we're laters. I'm out. Definitely get some sleep then. I'll see you later, Saraid. Let's just make sure it still works with factorial and stuff. And I didn't break absolutely everything. Yep, that still returns 120. We'll run, what, downwards funarg. Code 6.9, that's good. That is good. We'll do greatest common denominator. We get 8. Okay, well, it's working. It's not ideal, but it's working. Yeah, I think we're gonna have to do that thing where we actually use all of the instructions to build the adjacency matrix. Because we loop over all of the instructions that were given. And if they interfere, then we set, hey, they interfere in the adjacency matrix. But the instructions we're given only apply to a subset of all of the actual instructions. because we're only collecting the ones that need a register, which you can see here. See this big list? This is the list we're using of instructions, and you'll notice that the stores aren't on it, anything with no register allocated. And the issue is, I think we have to do that after building the adjacency matrix. Right? Which means that we're going to need like collect instructions char needs register. And then we'll say if needs register is non-zero, return only instructions that need a register allocated. And then we can just do something like this. Called object needs register. Oh, I named it the same thing. Needs register filter. And then we'll say if not needs register filter. So if it doesn't need, if we're not filtering, I guess that should be an or. So if that is 0, then just add it. But if it's non-zero and yeah. Hey, look, I fixed it. Did I fix it? I think I fixed it. We'll see. We'll have to go back to the arrays, right? I exited abnormally with code 1. Oh, because I did it from the wrong spot. I think I may have fixed it. Failed with code 5. I didn't quite fix it, but it is doing better. No, it's doing the same fucking thing. What's the issue now? We load the int array. We store the int pointer. We load the int array. We store the pointer. No. Then what do we do next? We load the value at racks into racks. Then we move that into first int. That looks proper. We then load 69 into RDX. We again load the beginning address into racks. We load the... We then load the value at... Yeah, we then load the value, so the first integer, into racks, and then we move racks into RDX. That's backwards. It would be fine if it was backwards, because we'd load this into racks. But why is this move happening? What is that move being generated by? Is that global address? Then we have load 7. That's what it's being generated by. Load 7. So what are we doing? We're trying to store 69 into the address of int array, right? Why is there a load here? That's got to be code gen. Where do we do IR load? There's no... Okay, here it is. In a dereference. Okay, in a dereference, what are we doing? What? So why are we seeing a dereference here? If I go to arrays, see, we need this dereference on the left because this is a pointer. This is a integer which we can assign to. So on the left side of a variable assignment, you can see that we say find the variable access on the left-hand side. We codegen the right-hand side. So this will codegen 69. And then we say if expression children type is variable access. So that means that it's not a pointer on the left with no dereferences. So if there's no dereferences, we can just store local, store global, do the regular thing with symbol to address. But the issue becomes, so when we codegen left-hand side, that doesn't really make sense to do. This is very broken. When a dereference is cogened, it loads the value at the address. We actually just need the dereference for type checking. Oh God. Right? When a dereference is cogened, it loads the value at the address. We actually just need the dereference for type checking when we cogen it as a result of the following call. A value is attempted to be used as an address in future instructions. This is not correct and obviously not ideal. Okay. When a dereference is coded, it loads the... Yes. A better solution would be to loop the amount of times that there are dereferences minus 1 getting the new address each time. Does that even make sense? So the left-hand side, when there's a dereference on it, like there is here, we actually want this to say int array, like this, right? If we were writing this in C, it would look like that. Oh God, stop. Jesus, fuck. I hate that Emacs has default assembler. What the fuck is that shit? Okay. So as you can see, this is what we want to do. We want to dereference int array at 0 and assign 69, which would be like this, right? It would be this effectively. And what's happening right now is we are saying dereference int array like that, and then assign that to 69, which isn't even valid C. You can't write it because this would just assign it to 69. But what's actually happening is we're getting the value here. So it'd be like doing this. Yeah, it'd be like trying to do this. Because this int array at 0 is actually equal to whatever's at the int array 0 in C. Whereas in our language, it's that is equal to the thing. So the problem is This is a memory address. This is a memory address. But this dereference is actually dereferencing when it really shouldn't. So maybe we should generate, and when we access int array, we do get the global address. So what if I did this? So if we generate iterator, okay, that broke everything. Don't we have iterator? Iterator is asserted to be something. We cogen the right-hand side, which is how we get 69. But then when we're cogening the left, why can't we use iterator? Why does that break everything? God damn it. Okay. This is a difficult one. This is a difficult one. I'm not going to lie. So we need expression children. Maybe that was it. Maybe we were just dereferencing null right there. That was it. Okay, let's check that out. What the hell's happening? 69 goes into RCX. We load. That's incorrect. Move int array rip into racks. I guess that's correct. So this is the, shouldn't that be Lee? How's this move? What? Oh, I'm so confused. Now we have load int array. With no adds. So we load int array, store it in first int pointer. We load int array. We load the value at int array and then store that into first int. We store 69. We load the address of int array. Well, this is closer. It's still not correct. So when we load int array here, we don't want to do a global load of int array here. This isn't what we want. We want to get the global address. But that's what happens when you do this. Okay, so we need to basically say iterator is a variable access. So we're going to have to do this no matter what. Okay? But everywhere that we said it was expression children, it's actually going to be iterator. Because iterator must have this type. So I should have one here. Right? Yeah. So what are we switching on? Address mode. Okay. Okay, I broke everything. How did I break everything? That works. That should still work. That still works. We just get a global load of int array when we shouldn't. It's fine. So now we load the iterator address. Okay. Jesus Christ. So whatever variable we're modifying, even if it's an index, blah, 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 we get it. We get the variable access address. Ideally, it doesn't have to be a variable access. This is so complicated. I'm going to do this later when I have more time. I don't have time. So yeah, just do expression children. Change this back to what it was. And then we'll say, yeah, to do. This is very broken when a deviant lows value, blah, 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 blah. This won't work, but everything else still does, which is kind of the most important. Like greatest common denominator, still works, baby. Got that exit with code 8. Okay, this is Pog. Thank you so much, everybody, for watching. That's going to be it all for now. Danny boy, thank you so much for following. That's going to be all there is for now. Thank you, everybody, so much. I greatly appreciate it. I've been streaming almost 7 hours, so I'd greatly appreciate as well if you could check out the Discord down below. It is a link, and I greatly recommend it. It's in the Twitch About section if you're on mobile. But you can join the Discord, and we talk about all sorts of things. We're friends, and we have a great old time. I really recommend joining. And I'll wave at you. If you join right now, you'll even be on stream. How about that? If you would like to catch any of my previous broadcasts, be sure to check out my YouTube channel, which is youtube.com/c/lensr, no underscore. The same name here, but with no underscore. And yeah, there you can find all of my previous broadcasts, from compiler development to a suicidal AI bot. So I recommend checking that out. There's some interesting things to catch there. As well, you can check out the GitHub and the Codeberg links down below to find my open source projects, which is all of my projects. And yeah, I'm going to, right after the stream, commit all of this stuff, and you know, then you'll be able to pull it and build the compiler exactly as it is in the state in this video. So thank you, everybody, so much for watching. I really appreciate it. I've got nothing more to say. If you'd like to say something, ask any questions, etc., now would be the time, because I'm about to go. Thank you all so much for watching, and I'll see you next time, okay? I love you all. I got nothing in chat. I'm gonna click the button. I'm gonna do it. I'm gonna hit the goddamn button. All right, I'll see all you later. Thank you so much for watching. I'll see you. Bye-bye.